morning again, and welcome everyone to this 47th event. Thank you for being here. This group is definitely united by a shared passion for large-scale production engineering, right? A feel for relentless dynamism, intriguing challenges, and blah, blah. Shared passion for large-scale production engineering. The reason I'm saying blah, blah, blah feel for relentless dynamism, intriguing challenges, it wasn't me talking. Shared passion for large-scale production engineering. The reason I'm saying blah, blah, blah feel for relentless. My bad on that. There was a bit of echo. This was an usage of, if anyone wants to hazard a guess, ChatGPT. As always, yes, Grab hosts this event once a year. I had this opportunity to talk again, and I was like, hey, let me go and try out. Can ChatGPT be something that I can use here, right? Fun fact, we have actually used ChatGPT in something that you'll be holding in your hands later today. The swag that you are getting, the logo that we had to print in there. I had a low resolution version of it. I had to step out to the airport to pick up someone. And then Sandeep, our dear facilities manager at Grab, who helps us to organize this, asked me for a high-res PDF. I'm like, yeah, give me a few minutes. I fired up GIMP, and it would have taken me at least half an hour or so. And I'm like, yeah, either I'm going to do this or I'm going to go to the airport. Searched up quickly, upscale images online, got 4 links. 3 of them wanted me to sign up for free trials before I could download the image. Managed to scale the image up 3x 4 times, so essentially a 12x scaled up image, which worked out very nicely, if I may say so, for the print, right? So essentially, I think the first time I heard about ChatGPT was when it was launched sometime, let's say October, November last year. And I would not be exaggerating when I'll say that this was the first time over the last 14, 15 years of my career where I was truly thrilled and amazed by what all the opportunities be, right? I've been using it on a day-to-day basis. Let's say whatever used to be earlier a quick Google search or a quick Stack Overflow search is now a ChatGPT search. It hasn't necessarily disappointed, but yeah, it isn't something where I'll say that, yeah, this is the only go-to thing, right? How is it going to play out for SR, for teams like SRE, for teams like DevOps, for teams like infra management, right? Think of it like this, for people who support teams internally, a whole lot of things is repetitive. Even in Grab, as we have made use of some version of automation, some versions of LLMs, but we are still in our early days, right? Some of the pieces that we have done is created workflow to help answer or create JIRAs for internal queries. We are looking and assessing how could we make use of LLM further to answer internal as well as external queries. Some places where Grab is already using it or experimenting with is, let's say Grab also has a food deliveries business similar to, let's say, Swiggy or Zomato. Not every restaurant uploads decent food images, right? That's where we are using it. For chat support, that's where we are assessing it. For user-generated content, that has taken off on its own. It's supervision, or rather, let's say, to ensure that the content is right is where we are looking at it and then see how we can do it, right? Some of the other potentials, be it in terms of creation of self-healing systems or places where AI can detect issues and diagnose the problem or even suggest or implement solutions. How is it going to help us, or how is it going to challenge us, right? In terms of helping us, it's definitely going to make things a lot faster. Imagine searching for how to roll back a canary deployment in Kubernetes in your favorite search engine, finding that link to the blog or Stack Overflow, going and searching for it, or simply getting the command and then updating it using chat further prompts to say, okay, this is the command, let me try it out, copy paste. Of course, the standard aspect of always try it out in stage first, but yeah, that's how things could change. In fact, I have been using it in my smaller projects here and there. And to a certain extent, I would put it anything between 30 to 70% efficient as compared to what I would do otherwise, purely using, let's say, search engines and Stack Overflows, right? So that's what I'll put it. That's the brief of it from me for today. Unfortunately, we still don't have any talks on AI or LLM in this audience, in this forum today. I'll definitely be looking forward to have one of such talks in coming days from anyone in this group, or if not, hopefully from Grab next time. Moving on to the agenda for today. Today, we have the first event itself, the first talk itself is going to come from the team who's going to take care of floods in Bangalore, right? Same time last year, we were hosting the event at Grab, and we had to move the event out by a month because the roads that you came in were flooded. And why was that? That is because the rains happened, the clouds burst. Jokes apart, yeah, it's not about the cloud bursting and rains, but rather about chaos engineering, right? It's much easier for us in terms of computing to say, hey, how could we make use of chaos engineering to ensure anything and everything that can go wrong will definitely go wrong, but how can we test it upfront? Chaos engineering helps us in that. That's the first talk from AWS. If only our dear BBMP could do it on the roads and could test it before rains, our life would be a lot easier. But yes, let's see how that goes on. That's the talk that Rishabh from AWS will be presenting. After that, something that seemed like a blast from the past, Apache Traffic Server and making use of it in hybrid cloud connectivity and encryption. That's something that Vineet from Yahoo will be talking about. Apache Traffic Server is something which originated at Yahoo as YTS or the other way around. But yes, YTS, ATS, this is something that has been used at Yahoo for a long time. And it's good to see that it's still being used in days of cloud compute and on-prem data centers in hybrid manners. So yeah. Then we'll break for lunch and two more talks to follow up. One about Kubernetes and VM monitoring at scale. This is something that Sumit and Prasad, along with, Sairam and Sumit Prasad from Myntra will be presenting. And to close the day, we'll have Anirudh from Grab talking about how does Grab manage configurations, patching, and all things server management using AWS, right? So that's something that Anirudh will be talking about. That's the brief of it. Post the event, there will definitely be networking session. In between, there will be lunch session. So for all the folks on the ground, do make use of this time to talk to each other, to meet new folks. I'm definitely envious of people in the room. I couldn't be there when I heard a bunch of familiar names. I wish I could be there, but yeah, hopefully next time. And looking forward to all the great talks today. And for folks who are in college, or even otherwise, do visit grab.careers. We have, given the present economic scenario, not too many openings, but still decent number of openings. We have openings for SRE, we have openings for data scientists and analysts, bunch of mobile iOS and Android openings, and some more openings not in India as well. Try your luck, you never know. So yeah, that's where I'll put it for the day. Thank you, and yeah, looking forward to all of the talks for the day. Over to you, Devanshu.
Thank you, Vanshu. I mean, you were pointing us to the right direction with the keynote. I think I had a talk probably before COVID, the last session before COVID or something, where we are trying to talk about what MLOps is going to do, but then it was pre-Chat GPT days. Chat GPT and the LLMs and stuff, we are at the edge. Probably still not understood it well. But obviously, this community should come up with more talks, as Anshu clearly said. So without further ado and delay, we are 15 minutes running, 15 minutes late. We'll take that slice from our lunchtime, as we always do. We'll put up stage Rishabh from AWS Support Engineering. Welcome, Rishabh.
Hello, am I audible? Okay, is it visible properly? Guys, can anyone confirm? Okay, how about now? Is it audible properly? Okay, perfect. Shall I start? Okay, good morning, everyone. So my name is Rishabh, and welcome to 47th LSP Meetup. So, quick round of introduction about myself. So, my name is Rishabh, and I'm working as a senior cloud support engineer here at Bangalore office for AWS support engineering. So, I'm a Linux, EC2 Linux subject matter expert, and I've been with AWS support engineering from close to 6 years. And before that, I've worked with Red Hat, which is well-known company, and another before that I worked with PubMatic, which is one of the ad tech company. So that's what a quick round of introduction about myself. Moving further, today's agenda for this meetup talk is who we are and what we do. So as a senior cloud support engineer, what we do as a team and who we are. Then we are going to cover about chaos engineering, then why we need to have chaos engineering or why we need to practice. Then what are the different phases of chaos engineering? Then what are the different ways to inject chaos into our systems? Then chaos simulation experiments and tools, followed by a demo. So I'll be demonstrating the chaos engineering service by AWS, which is AWS Fault Injection Simulator, and some common FAQs which comes to people's mind when they start with their chaos engineering journey, and followed by then question and answers. So that's what we are going to cover today. Okay, so starting with who we are and what we do. So I'm part of global support excellence team at AWS support engineering. So it's basically global team, and we have offices spread across different geographies, and we follow the sun model, and we support our customers 24/7, 365 days. We also collaborate with our global peers and product development teams. So most of the, like, you might be aware that most of the services that AWS brings for their customers, they are basically taken as a voice of customers. So we act as a voice of customers, and we take that feedback from customers, and that feedback translates into the majority of product or services that we develop. We also work with product teams to onboard new services under AWS platform. Then we work on troubleshooting escalated technical issues. So we have a frontline support teams. So they do provide support for the issues that customers face. But when there is a sort of escalation or a kind of extensive deep dive is needed, that's where we come into the picture. We also, with that escalations, we also suggest customer best practices to perform in the cloud in terms of cost, in terms of reliability, and all this stuff. Next is we also build tools and automations for our internal support engineers, as well as for external customers as well. So again, while we are building those tools, we basically interact with customers, we understand their requirements, and that basically comes from the interaction from customers, our support engineers and all. And we basically analyze that data and build the tools for customers. So for example, you might have heard about AWS support automation workflow, AWS SAW. So that is one of the initiative which is built under this support and tooling automation. In that SAW, basically, these are documents, automation documents, which you execute against your instances or infrastructure or resources. So basically, they are kind of self-service automations where you can fix common issues which you may face in your infrastructure. So along with that, we also create contents for customers based on the data that we analyze. So you might have seen knowledge center articles, then knowledge center videos, then repost documents and all. So these all things we as a team work at under global support excellence. So that's what we do. Okay, moving to our topic. It's regarding the data center or server failures. So this is stats by Uptime Institute. It is one of the organization which provides data center consulting and management services and operational services. So they basically have gathered some data and presented that what sort of failures or what are the major reasons for failure that happens in data center or the server failures. So if you see the stat, major of the failures that happens, almost around 63% of that, it happens due to software configuration issues or network related issues or network gear related issues. And some 2% of issues happens due to hardware related things where your motherboard fails or RAM chips fails and disk and all this kind of. So if you see collectively around 65% of issues that happens due to hardware, IT hardware or network and software, right? So let's take an example like what is the probability of a specific server or a data center to fail. So it is a common a formula or math for that. So MTTF, it's mean time to fail, where server, it's like a time between server has went operational till the time it fails. So basically it's straightforward formula, like mean time to failure for one data center is mean time to failure of one server divided by the total number of server you have. So just assuming one host, it lasts for 10 years. So that way failure for 120 servers in a data center would be around 1 month. So expecting like a server failure is going to happen per month basis or in a 1 month. Okay. And similarly, if you have multiple servers in a data center, like around 12,000 servers or more than that. So that basically goes down with around 7.2 hours. So every 7.2 hours, you are going to see either a software level of failure or either a hardware level, network related glitch, something like that. I mean, when I say failure, it's nothing just only a hard drive is going bad or RAM chip is going bad, nothing like that. It could be a software as well, right? So that's, I mean, when we say server failures, I mean, what are the mechanisms we can use to tackle these failures, right? We can hire more monitoring team, I mean, engineers to monitor that. But again, when it comes to a scale of thousands of servers in a data center and when it spans to multiple geographies, it becomes very hard to perform those manual monitoring and all, right? So that's where we start automating the things. But thing here is we can monitor the things for the known conditions, right? But we don't have monitoring in place for the unknown conditions, right? So that's where our CTO of Amazon, it's a very famous quote of mine as well. So we need to build a systems that embrace failure as a natural, right? So when things fail, it hampers or affects our applications, but we should design a system which basically, thinks as it as a natural occurrence and it should not hamper our application. Okay. So what exactly he means by embracing failure? So is it something we should let system fails and be seated like it is? No, it's not like that. So what he means about embracing failure is we have to build a systems which basically does not affect when the failure happens. It should not affect the availability or the customer experience of our customers. Okay, so that's what he explains about that. So how we are going to do this? how we are going to embrace failure as a natural occurrence. That's what we are going to see in this hour of talk. So going forward, let's take example of simple distributed complex, simple distributed system. So it has many components. Overall, like you have client, you have a server, and in between you have a network. So it's just a single round trip when you have a communication between client and server, where a message is sent over the network to server, and server updates its states and reply backs to the client, right? So think about this is for just one request, right? So we have a services for multiple services where thousands of request hits to these applications, right? So failure can happen at any level or any point and at any time, right? So when distributed systems become more complex, it looks like something this, and detecting failure in this, it becomes very hard. So this is a typical service dependency diagram of Amazon, then Twitter and Netflix. Okay, so they have these kind of service interrelationship, and finding failures in this, it's very hard. So now you might have landed across failures related to disk. Okay, before that, I have a question. How many of you have monitoring systems in place to monitor the disk? Just a simple part, disk. And what parameters you monitor? IOPS, okay. What else? Sorry? Free storage. Okay, good one. What else? Sorry, can you come again?
So I'm saying is, unless it is some very data intensive system part of your entire system, usually you don't monitor disk. You monitor critical part of your system, like it could be requests per seconds, it could be latencies, anything which impacts your customer experience. If that is working fine, you don't care if your disk is degraded and all those stuff.
I'll come
Unless
to that
it is
point.
database system.
Yeah, I'll come to that point.
Yep.
It's a really nice one. I will come to that point. So we got three answers. One is IOPS. Second one is a free space, and one you were talking about why to monitor the disk if we don't have a. Yeah. Okay, smart parameters. Good one. Open telemetry. Can you just Okay. You're saying about the monitoring service, open telemetry you're using to monitor the disk and on your EKS cluster. Okay, understood. Oh, perfect. So let's take a simple example of free space, right? So you might have monitoring systems in a place for monitoring free space where you are monitoring different mount points, how much free space is available. Okay, so the failures can happen due to free space as well, right? So you may think of the case where there is no space available on the disk, and that's where you put a monitoring on top of that. But making things more complicated, you can get a free space left on device error when when you have a space over disk, right? It can happen due to small files where you exhaust your inode limits of a disk, sorry, file system, and you still are not able to figure out, right? So these kind of things happen, and these things, are not tested in the testing environment or when you run a test against your infrastructure or application and all. So these things are not taken into consideration, right? So now coming to your part where you were saying about why to monitor the disk and all. So now think about application where it is behind a load balancer, right? And it's basically there is no space left despite having space on the device due to inodes and all, right? So if you don't have a monitoring system in place where it's not monitoring these some low-level parameters of the disk, your load balancer will still think that I have this node healthy or I have this application healthy. And if you are relying on some sort of logs where you're capturing some data from the logs to have some later processing, right? Your load balancer will still send the request and that will go to a black hole kind of thing. And you will not be able to trace out that why is it happening. And that specifically happens when you have a kind of a load-based scaling policies where you keep launching and terminating servers or instances. It's very hard to figure out those things. And that's the reason we are going to see in this topic, like how to find the unknowns, and the practice, it's called as a chaos engineering. Okay, so coming back to the problem about disk space, so what are the remediations, or what are the things we can keep into check? First, you can keep a centralized logging, then you can keep we can keep something like log rotation into a place which will rotate after a certain amount of logs are generated and all. So that's where things we can perform. But these things, again, I said, cannot be done into a testing phase, or we don't think about that. Okay, okay. Now, moving to testing part, as I was explaining earlier. So testing basically we do for the applications, for the code and all this stuff, like unit testing, functional testing, and performance testing, where in performance testing, we calculate how much infrastructure is required for one request, and then we expand, or we calculate based on what is the total volume we are getting, right? So these testing basically are good to do, but when it comes to a distributed systems, they are not enough, to design reliable systems and all. So, and again, when we test against the known conditions, right? So let's say if you have a login page, once you click a button, it should go to a profile of that user or something. So you test about, okay, if the login button is working or not, right? If it is not working, then you go into a code and check why is it not working. But what if it's not able to connect to a database? What if the systems behind that button, whoever are responsible you to redirect to that page, is not working, right? So we don't think about that aspect, right? And that's where the traditional testing methods for the distributed systems are not enough. So how we are basically tackle those kind of situations where the traditional testing is not enough? That's where the practice comes in, called as chaos engineering. So chaos engineering is basically stressing the application or system with some sort of a known experiments or some sort of test, or by putting some dummy workload or production workload as well, and in a controlled environment. Either you do it in a testing environment, a lower environment, or you do it in a production environment. Then observe how system behaves in such disruptive events, and then find out the gaps. What are the gaps into your monitoring system or alerting system, or any gaps, like how the application behaves and then work on those gaps to improve that it will not happen again in 3 a.m. on a weekend. So that's what the chaos engineering is. So chaos engineering, it's not just you break things randomly, but it's a systematic practice of doing things step by step. And it just not improves the resiliency of your application, but it also improves performance. It uncovers the issues, hidden issues that you might not have thought about, and it exposes the blind spots in terms of monitoring, then observability, then alarm, then the operational procedures. If certain things of issue happens, how your operation team behaves or how your operation team performs certain steps. So it exposes gaps in that as well. And there are many more in terms of RPO, RTO, and all these kind of things. Okay. So it's there's a framework defined for following the chaos engineering. It starts from steady state, Then second phase is planning the hypothesis, then running the experiment, designing and running the experiment, then verifying it, what are the gaps that your system or how the system behaved, and finding out the gaps, and then improving or working on those gaps so that those will not happen again. So that's what the whole 5 phases of chaos engineering is. So let's start with steady state. So for steady state, understanding a normal is the one of the important aspects. So this is something important phase of chaos engineering where you identify what is a steady state of your systems or your platform. So there are certain metrics that one has to consider which depicts that systems are steady. So for example, take a example of Netflix. So Netflix, it's so-called pulse of Netflix. So they basically monitor the play starts per second. So when you go onto a Netflix portal, you open a movie or series, and once you click that play button, they monitor that number of plays or the starts being clicked. And that basically metrics ties with their operational metric as well as a customer experience metric, right? So if there is any predictable fluctuation in that metric, if it goes down or if it goes up, that means there is some sort of abnormality happening with their platform. Similarly, for Amazon, we have orders per second. So if same kind of metric, orders per second metric varies, it is going to show that there is some sort of abnormality happening on the platform. So similar way, when we are practicing chaos engineering, we have to ensure that we monitor the correct metric. And if you are not aware like which metric to monitor, we have to sit and discuss that which metric is tied with our operational metric as well as the customer experience metric. So we have to bring that 1 or 2 metrics, whatever it is, and we have to keep monitoring on that. So the key point is measure, and again, because if you don't find that specific metric to monitor, your whole chaos engineering experiment will not be successful, and probably we may land into some sort of a false conclusion, which we don't want to. Next part is hypothesis. So hypothesis is something thinking of what could go wrong in our systems. Okay, so take example of Amazon. So you might have seen this page. I'm sorry, it's very small, but by some sort of texture, you would be able to guess where I'm pointing it. So in Amazon's homepage, you have a pane called Shop by Category. Okay, so it basically categorizes the products for you in terms of electronics and all this stuff. And then you can simply click and traverse all the products, right? So think about a situation if the Shop by Category pane is not functioning properly, or what if it fails to load on the homepage of Amazon.in, right? So what should happen in this case? I mean, shall we show 404 error on the front end page, or shall we just remove that pane and just keep it as a blank, or shall we gracefully degrade the page so that that error can be falled back and customers are not able to see it? So this is again from the front end side, right? What happens in a back end? So systems who are responsible for showing that categories pane, right? What if there is a network latency in the backend systems, or the database which basically from which the values are being pulled in, it's stopped or it's not functioning properly, right? So these are kind of hypotheses which we need to list down when performing the chaos engineering experiment. So some of the example hypotheses are, what if this recommendation engine stops, or load balancer breaks? If you have a caching mechanism, what if the caching is not happening properly, right? What if the latency, that single digit millisecond latency shoots up to 3-digit, 300 milliseconds? Or what if the main database stops? So these are all examples of hypothesis. And the same kind of hypothesis, we can list down by gathering your team. And again, this chaos engineering or listing the hypothesis is not something just an infra team has to do or SRE team has to do. It has the whole team or the stakeholders whoever are responsible for that specific platform or that specific component that you are going to test. So they have to come, they have to sit and draw all sort of hypotheses that for their specific components. So let's say for site reliability engineering team, they can think about the infrastructure level, right? So we have a DB reliability team. They can think from the database perspective. So like that, they can build up all the hypotheses. So the key part of hypothesis is just make it simple. Don't go into very complex hypothesis. Break it into simple parts and focus on the system that you believe they are resilient enough. So that's the key part from hypothesis. So next part is designing the experiment. So in this, we basically design the test or the experiment which we are going to test on our system to ensure if it is resilient enough or not. So in this, we have to pick one hypothesis at a time. So when we are in the hypothesis phase, we might have list down 50 hypotheses, but it's not something we have to combine it in 50 or 10 and then execute it at once. It's not something like that. You have to pick one by one and define scope of your experiment. So once you pick the hypothesis, where we are going to apply this, what would be a scope? Is it something only a dev we are starting with, or staging, or then prod? You have to define scope of the experiment. Then know the blast radius. So when we are performing the experiment, what is the blast radius of that? How many customers are going to affect? Even if it is a testing environment, whoever team is using that, how many customers I think they are as a customers, how many of them are going to affect. Then if it is a multi-region, then what geographies are going to affect with that. So that we need to define in the experiment. Then what are the metrics we are going to measure? So this is again important part, and I've been focusing from the very first slide of this chaos engineering. So without knowing the metrics to measure, one should never start the chaos engineering experiment. If we are not sure about what to measure, go back again in the steady state and find out the metrics that we are going to measure in this experiment. Next is notifying the organization. So who are the stakeholders will be notified in this process, and what sort of notification is going to be sent. Because when we are testing, things will go, there will be a disruptive events, and the teams will be not aware of that something like chaos experiments are happening. And last but very important part is having a abort button to return things back to normal ASAP. So this is a very important when you design the experiment, is to have an hard stop button. So when, let's say, while performing experiment, if things go out of the control without having that intention, so we should have a stop button that will, bring the systems back to normal within few minutes or seconds. Okay, and important thing is don't test it in the production from start. Do it from the test environment, because we have habit sometimes to apply some things on a production, and then it goes into some bad way, and that's where we still have to have this abort button and start with the testing environment. Okay, so next is learn and verify. So in learn and verify, it's another important phase where we find out the gaps. So when we find out the gaps, we need to focus on this 4 parameters. The very first is time to detect. When that error or abnormality was detected by monitoring systems. Is it something your customer is going on Twitter and blabbering something on a tweet that, hey, the systems are not working, or I'm not able to log in, and then you detect it, hey, there is a problem? It should not be like that. It's something the monitoring systems or your team who is responsible for monitoring, they should be able to detect it. Then once the error or the abnormality is detected, what was the time for notification? When the issue got escalated, whoever the teams involved in the escalation. Then was the graceful degradation kicked in? So if let's say you have a front-end application, so if you find some part of that is throwing error, like Amazon's I show, so was there a graceful degradation happened? So that thing, and what was the time for things to come back to normal? So how much time it took for things to come back to normal and stable state? So these things are data points we need to gather once we start with the experiment. And the final is start with the post-mortem analysis. It's RCA. So these are some 5. I mean, every organization you guys follow some different way of doing RCS, but these are some sort of common things which I personally have noticed from my experience, like what happened, timeline of the issue, then what was the impact to our customers, then why the error occurs, and what did you learn from that error, and what are the steps we are going to use to prevent it from happening again. So the final one, 5th one, is the very important, and that takes to the last phase of chaos engineering. It's improve. So in this, you may find many things like monitoring, in terms of code related things, database related things and all. So you may find 10 gaps when you are running the experiments. But thing here is, it's not something you have to fix all 10 in a one go. You have to prioritize things, what are affecting your customers most, and where you think or you have an assumption that my systems are more resilient, and you found a gap in that. So that things you need to prioritize and start working on that part first. And then you start with the low priority experiments. Because, I mean, the major outage can happen with the very small things. As I explained, if there is an issue with the disk, it can lead to a major outage. If a single route in the network gets changed, it can lead to a very major outage. It's just one entry, but it impacts the whole platform. So that's the thing. Now, till now we have seen all the framework of chaos engineering. So what are the ways we can inject chaos into our systems? So commonly there are different ways. First is resource level chaos. So this is specifically we inject on the operating system level, like stressing out the CPU, memory, then IOs, net kind of resources, and different subsystems of the operating system. So in this, there are many OS level tools available, like you have a stress NGs and different stressors, which we can use to create a resource level chaos onto our systems. Next is a network and dependencies level. So this is very important. Many of us assume basically our network is very reliable, but that's a false assumption most of people we have, because whatever issues happen, majority of those contribute to either a network latency or some sort of a network related dependencies issues. So in this, we can think about using some firewall rules to block some sort of traffic, messing with host files, local DNS resolutions and all, or using some traffic shapers like TC to drop some sort of packets on OS level and see how the system reacts to those events. Next is application process level. So here we can test the crashes by killing application process abruptly, or stopping some service like databases and caching servers and all, and see how systems respond to that. Next is infrastructure level. It's as simple as stopping the VMs. You can start from that and move to some more deep depth on terms of infrastructure level. And people level, I'm not going to cover this because we humans are very good at creating chaos. So I'm not going to cover that part. Okay, next part is tools. So what are the tools available for chaos simulation? There are lots of tools, and every tool has some specific use case tied with it. So not a single tool can cover all the chaos experiments, but there are some famous tools like which includes open source and license as well. So first one is a chaos toolkit. So it's again open source community users contribute to that. Then we have a Gremlin. It's a license tool. It comes with nice UI level things and you can simulate the experiments. Third one is the famous one. Most of you guys might have heard about this, Chaos Monkey, which is by Netflix. It's again an open source tool. Then we have Chaos Mesh. It's again open source, and the AWS native tool, so which AWS has designed based on chaos engineering principle. That is AWS Fault Injection Simulator, FIS. So it's a pay-as-you-go model. The number of experiments and the number of times you perform, the way you pay for that. Okay, so next is some details about fault injection simulator. So this is a service that we heard from our customers' feedback and all, and we designed this service called as FIS. It's kind of a managed chaos engineering service, which we can perform onto our AWS infrastructure. So some features of that, it's very, I mean, for beginners who are just, yet to start the chaos engineering, or they just want to try things out or play around that, it's easy for them to start with this service. It basically simulates the real world conditions and safeguards as well the service provides. So in this part, this FIS service, one doesn't need to install any sort of agents or scripts and all. We have ready-made templates available for certain types of simulations. And the service is consumed using management console, AWS console, and CLIs as well. So if you're a beginner into a chaos engineering, you can simply play around with the GUI stuff of this service. And once you are comfortable enough, you can move to the programmatic way, or you can automate things, integrate with your code suites and all this stuff. As I explained, it comes with the experiment templates, pre-existing templates. I will show at the time of demo. Then you can share with these templates with others. So once we have template design, we can share it with other accounts and all. So there is no need to recreate the templates in another accounts and all. We can run multiple sequence and parallel experiments. So experiment those needs multiple steps to be executed in parallel. These kind of things can be run with FIS. And it targets all level of systems like host, infrastructure, networks, OS, and all this stuff. And these simulations that we do, they are specifically done on the control plane side. So for example, if you want to simulate API throttling, so API throttling is a very common thing in AWS. People might have seen. So when we simulate that, it goes into a control plane and restricts the API rate. And that's how we see the throttling. So it's not something faking into a metrics and showing you some different values and all. So it's actually simulates that stuff. Safeguards, it's important, like we can define stop condition alarms. As I explained, that we should have a hard stop button. So it works on that theory. Then we can integrate it with Amazon CloudWatch, so to set the stop conditions. Then built-in rollbacks, if let's say experiment fails, or if due to some reason it couldn't proceed further, it will be rolled back to a normal state. And fine-grain IAM controls are provided, where we can restrict which resources to be targeted and what actions needs to be targeted. It's a typical architecture of fault FIS service. So it basically consumes it can be consumed using console and command line interface, where we create experiment templates and we pass that experiment templates to a service called FIS engine. So it's a control plane part from our side. So that FIS engine runs those experiments again, the resources that we have selected, either based on tag, role, or a specific resource ID. And there is a safeguard mechanism using Amazon Event Breach or CloudWatch alarms and all, and can be integrated the monitoring with third-party logging solutions as well. So this is a typical architecture of FIS service. Okay, so it's time for demo. Let me stop this. Okay. Excuse me, I have to stop this and my browser is not visible over here. I have to share the browser. I have to share this browser now. Earlier it was, this one. No, this one. This one.
So again, go back to that. You wanna have to do it again.
Okay, fine. Should be fine. Okay, so speaking about ready-made experiment templates when you are interacting with FIS. So currently supported services by FIS are EC2, EBS, ECS, EKS, RDS, and some API-related control plane level things. So these are some ready-made templates. You can simply copy these templates and just execute it. That's it. So there are many use cases like stopping the EC2 instance, then some SSM documents as well. So let's say, for example, you want to run some custom experiment, which is not defined in this template, some OS level things. We can write a shell script or Python script and you add it into a SSM document and execute with this experiment. So we have that customization options as well. So let's move to the experiment part. Okay. Okay, so these are experiment templates that we have, I mean, I have already created. So first is for the API throttling. Second one is stopping the instances. So I have a basic web setup created. It is just 3 instances spanned across different AZs in Mumbai region. And it is configured with behind load balancer, application load balancer. So it shows this kind of web pages. I have just dumped the metadata information of instance as a sample web page. Okay, so in FIS, okay, and I have configured the hard stop on the ELB healthy host metric. Okay, so if my healthy host count goes below 3 instances, the experiment will automatically stop. So that's the abort button I have configured. The same way you can also configure it for your experiments. Okay. Now I will just okay. In this, I've selected. I mean, when we configure the experiment, we have option to select the resources. Either we select the resources by their name specifically, or we can select using roles or tags that we have given to resources. So currently, I have selected based on the tags. So, okay, let me show. Okay, so the tags that is env equal to prod. So whatever instances I have with this tag env equal to prod, those instances will be selected in this chaos experiment. Okay. So currently, if you see, I have these 3 instances, web 1, web 2, and web 3 running. Okay, and I'll just start with the experiment now. Okay, so once I start it, it takes some few seconds to initiate that and to do some internal logic. Okay, and all the logging of this experiment will be shown over here in log section. So just give few seconds. Okay, now here you see this experiment has started. We'll start seeing some sort of logs that which instance type, I mean, which instance the experiment is going to select and all this. And here you see the experiment state is running. And if I go and see here, I'll see that this web 2 instances, it has selected to stop. Okay. But when I go and hit my load balancer, I'm still able to see the page. Okay. So this is, I mean, it's very simple example, but think about the production system where you are maintaining the state or sticky sessions with that specific instance, right? And if certain kind of failure happens, that session will be lost. When it comes to payment or kind of things, it is more sensitive towards these stickiness and all this stuff. So that kind of things we can simulate over here, and we can find out the gaps and unknowns in our systems. Similarly, I have another example of simulating the API failures as well. Okay, before that, let this experiment stop. It will take a few minutes to stop, but till that time, I will walk through a different experiment. Okay, so I have this API failure. So while launching EC2, you might have seen that you got internal error or sometimes request limit exceeded and all. So out of that, I've just simulated the internal error for now. So here, I'll log in. Okay, so here I just have configured one CLI for launching the instance. Now, okay. So this basically it's just a CLI command to launch an instance. Now I don't have the experiment running, but now I'm able to launch the instance. Now I'll start with that experiment of EC2 API failure. Okay. So the beauty of this testing the API failure is it's not done on the whole account level. We can granularize that for a specific IAM user or specific role. So that's the important beauty of this service, so that we are not going to affect the whole infrastructure that we have. So now it has gone to running state. Now if I run the same command again, it's going to throw the error. See, now you're able to see that internal error. So we have simulated that on exact control plane of EC2. We have injected that fault, and that's where the error is coming from. So this example is very simple, but we can integrate that with our CI/CD pipelines and all to test how system behaves when this kind of error happens. Okay. Yeah, just 2 or 3 minutes it will take. Yeah. Yes. Okay, so going back again to the first experiment, the stop guard or the safeguard I have set up, it was for it went into alarm state at the time, and my experiment is already stopped now. If I go to the experiments, this was stopped. This is one we selected to stop the instance. So if you see in the logs, it will view as a plain text. It will show you log line something like experiment halted by a stop conditions. So I have set that guardrail to stop that experiment if it goes beyond that control. Okay, so let's move back to our presentation. Okay, so common FAQs. So while we are discussing the demo, the practice of chaos engineering and framework, you may have questions like now how I should start with that, or some sort of questions. So the very common questions our customers come and ask us is like, how this chaos engineering experiment should be, whether it should be a one-time activity or a game day or a continuous testing. So again, like chaos engineering it's a journey, and it's not something that at specific point one has to start and at specific point one has to end. So it's a continuous journey. You can pick it from wherever you start, and you can just work with on that path. So starting with small experiments, it's important, and slowly once you build confidence in those experiment and you have a trust on your system that they are going to stand in the turbulent conditions, then you can move those experiment to the higher environment and see how systems behave and fix those gaps over there. And it needs to be, it's a continuous journey as explained. So next is, it's a common question. We have a good quality of operations team. Do we still really need a chaos engineering? A short answer is yes. The reason being is the quality can be defined in different aspects. Probably team is good in monitoring things, but team may not be good in following the SOPs. There may be some misses and all. Or probably when we say quality, it can be measured in different metrics or different angles as well. So it is good to verify our hypothesis or our assumption of our team as being good quality. And that's where the chaos engineering is going to, show the blind spots or the improvement areas that we can perform, be it on a team level or be it on a systems level as well. Next is, where do we start? What experiments we should choose? Here, start with smaller experiments. Focus on the one component of the system and build test experiments and then run on that. Once you are comfortable enough, move to some bigger experiments like having a game day or something like that, or some bigger drills, and see how system behaves. Does it have to be in production? No. Start with lower environments, testing, development, and fix the things where once you find out over there, and then you move to the higher environments like production and all. Last part is FIS uses SSM agent. So as I explained earlier, when we are running a custom experiments like tweaking things on OS level and all, so it basically uses SSM agent, and those automations or the scripts are passed via SSM agent to OS. So for some, it may be a problem that they don't want to run some external agents and all. But SSM agent is something you get a more exposure to do some more automations. So it's not just of testing chaos engineering, but with that you can run more diverse automations and all this stuff. So I explained about earlier the tool that we have developed, support automation workflow, that also uses SSM agent to pass on or to execute the automation. So that kind of benefits one can get via this SSM agent. Okay, so final words. Chaos engineering is breaking things in production. So start with small experiments. Once you build confidence, move up to having some bigger experiments or clubbing few experiments in one and see how it works for your system. Remember, when you are injecting a failure, you have to have an excellent monitoring and alerting program. Without that, one will not be able to understand the impact of that experiments and measure the blast radius of that experiments. So some of these failures that you may design can do a real damage. So first injections are on test. Make sure you have those injections on test instances where there is no customer traffic. And then you move to the real world, production instances. And last but not least, it's test, test, and test more. It's all about building the confidence. So once you're confident enough, you are good to go to say that my systems are resilient. Final words, there's a famous quote by Benjamin Franklin. I like this most. If you're failing to prepare, by failing to prepare, you're preparing to fail. So that's what I have for today's sessions. I'm open for questions. Anyone?
Let's take question and answer during the lunch because we are already running sort of time. So we'll be taking during lunch. That works?
Yeah, go ahead.
This FIS which you're talking about, right? Because I want to ask this question now because we're in the same context. So you said in the first slide that 65% is because of the hardware, right? Most of the problems we face. So if you take out the 35%, which that 65% is abstracted from us, we being the consumer, right? For the 35%, okay, we'll do the chaos engineering, what you said. But the tool which you showed me, the problems which you face, right? Like the disk gets disconnected automatically. Like we don't know what happened back end. And suddenly the VM, for some example, like the VM is moved to a new, virtual machine. So virtual machine is moved to a new hypervisor. It suddenly acts like normal. So I'm just giving what I'm saying. Probably because one of the RAM, the DDR5 is dead. So instead of it having 64 GB, it had only like maybe 2 chips, but it came down to 48 GB. So these things things happen at the hardware level. Now, how do you being the cloud, IS, infra provider, how can we simulate that?
Okay, so
Because we are doing chaos engineering from our side at our level.
yeah.
How does AWS do because you have to do chaos engineering at that level, right? Hardware.
Okay, so your question is customers can perform chaos engineering on systems level or application level, but how AWS performs chaos engineering at their level? Is it that question?
So the question,
Mm-hmm. Mm-hmm. Currently, from speaking from the EBS side, we have, I mean, this FIS service, our development teams are still adding some more experiments and all these things. So currently, recently, we added a feature called pausing the IO. So it's as good as what happens if something happens to our underlying storage level at all. So you can pause that I/O using that and see how the application behaves on that. So it was a recent feature added a few months back. So that kind of things are still. I mean, service is still evolving. We may not find all the use cases currently, but we still are adding few features. So EBS IO was EBS side things was the most requested by customers because they have persistent storage and all these kind of things, databases and all, where it is very hard to test if the volume level things go wrong or if their IO level things go wrong. So we added that experiment into FIS now. Yeah, I mean, certain things which are not in customers' control, they won't be able to simulate that. But we do have the stringent monitoring in place that basically performs that as well. So we do monitor those stuffs. Yeah, yeah, yeah. Any more questions? Yeah. Thank you.
Okay. Yeah, it's working. Ah, yeah, okay, that's better. Yeah. Okay. Sure. Sure. Yeah. Hi. Hi, everyone. I'm Vineet. I work for Yahoo as a principal engineer in production engineering. Is it fine now? Okay.
Let's fill up your teacups and we'll ready to start the next session.
No, that's okay. I think everyone knows Vinith. Vinith is probably speaking third time in this forum. One was in remote sessions when COVID. Okay, so Vinith is a principal engineer with Yahoo and primarily plays with Hadoop systems and all. So back to you, Vinith.
Yeah, thanks. So today's talk that I'm going to present is a bit of interesting one. Many of us use proxies only for, its basic functionality. Either it is forward proxy for or reverse proxy for HTTP. But this talk is about how we leveraged Apache Traffic Server, which is one of the popular proxies, to establish connectivity between our on-premise data centers and the cloud, and using a native solution rather than relying on networking-based utilities. So that's me. So we'll have a brief about what Apache Traffic Server is, terminologies in Apache Traffic Server, then two use cases. One is what we call as auth proxy, which is enforced, which enforces OIDC OAuth for UI. And the second is cloud proxy, which is for establishing connectivity across, multiple data centers or cloud or whatever. So before I proceed further, this has been like a presentation over the years across multiple sites, and a lot of people have been working on this in Yahoo over the years. So just wanted to mention their names. Yeah, so ATS is a high performance, scalable traffic server, mostly used for forward and reverse proxying HTTP traffic, and can be is usually configured either as forward proxy or as a reverse proxy. There is one other mode called as transparent proxy, where a user doesn't necessarily know that there's a proxy in between. Usually, as I said, it is HTTP traffic, but Apache Traffic Server can do a bit of layer 4 routing as well, which is only for TLS web traffic. So a few terminologies. Origin server is the server that you want to protect. Sorry? Yeah, TLS. So TLS or SSL is more or less the same. So the modern version of SSL is called as TLS. So there is no difference as such between SSL or TLS. The terminology is used interchangeably. It is the same. So origin server is a server that you want to protect. You will have your content there. You would put a proxy in front, which usually is called a reverse proxy, and you would, have the cache content. And similarly, the origin server can also be a client in some cases, where if it has to talk to an external service over the internet, you would first connect to a proxy and then connect. Then it becomes a client, and then the proxy that you are establishing is called as a forward proxy. So forward proxy is where I explicitly connect to a proxy to connect to an outside world. Reverse proxy is something that I need to connect to some service of mine that I'm hosting, but I would not expose the service directly. I would put a proxy in front, and then that would, a reverse proxy is more or less like a transparent proxy. Now, there is one, as I said, the one more thing called as transparent proxy, where clients don't know that there is something in between that is doing this proxying of data. Right. So, as I said, for non-HTTP traffic, or even for HTTP or TLS traffic, there is this SNI header called server name indication, which is basically used for selecting certificate based on a given domain name. So it is like a virtual service where you would have multiple websites being hosted on a single server, but you would have different certificates or different FQDNs that need to be picked up based on the SNI header. Similarly, but using the SNI routing, I could actually, do some kind of a layer 4 routing on an Apache traffic server, where I can say that if I'm trying to connect to, let's say, so in this example that you see here, if I'm trying to connect to, let's say, service1-example.com, then based on the SNI header, I can route it to this destination host called app-server55. But if I'm trying to connect to a different using a different FQDN, so like service 50, service 2, then connect to app server 56. Now, keep in mind that this is not just HTTP traffic. This can be any RPC based traffic that is TLS encrypted. So here the Apache traffic server is not actually doing any HTTP kind of proxying. Once it gets the raw bytes, it checks the TLS client hello message, which will have the SNI header, which will contain the SNI host name that the client is intending to connect to. And then the traffic server relays, it establishes a tunnel between the client and the app server. So there are two kinds of tunnels here. One we call as a full blind tunnel, the other one is called as a partial blind tunnel. So in the case of a full blind tunnel, there is no TLS termination as such happening on the traffic server. It is directly, so the TLS connection is directly established between a client and the target or the origin. In the case of a partial blind tunnel, the TLS termination happens. So the advantage with a full blind tunnel is if I am trying to do a mutual TLS connection from my client to the destination app server, to the origin, then I can establish this mutual TLS with a traffic server without terminating the connection, because otherwise it will not be possible. The other option that Apache traffic server provides, that we will see in detail later, is something called as a TLS bridge. So a TLS bridge is between, let's say you have two networks, whether one is in, let's say, an on-prem in your data center and the other one is in cloud, and you have to traverse through untrusted networks. What you can do is you would establish a bridge where you will have two Apache traffic servers. One is called as the ingress and the other is either called as a peer or egress traffic server. What they would do is this is plainly for HTTP traffic, but can be used for TCP based communication as well. So here what happens is a client explicitly states, connects to a proxy using HTTP connect method and wants to hit a destination, let's say service.com. Then the ingress traffic server, this TLS bridge plugin intercepts the traffic and then sees that, okay, for service.com, I have been configured to connect to my peer, and it establishes a secure tunnel, which is TLS encrypted again. So between the client and the service, they need not do any kind of SSL encryption. They can just be plain HTTP. And the ingress and peer would encrypt the traffic for you. So you don't need to establish any kind of VPN or some kind of a network crypto gear between these two and securely communicate between the client and service. So this is if your service doesn't want to, if you're not doing TLS directly with your service. And the other advantage is that, you know, if you are doing TLS with the service, then it essentially becomes a double encryption. That's all. So between ingress and peer, there is, you know, a secure tunnel established, and data is communicated. You know, so it kind of it kind of forwards the same connect that it receives on the ingress to the peer traffic server, and from there, you know, the client communicates to the service. This is also essential in use cases where you don't want to open too many outbound ports to your, you know, from your network to an external service. So you would only, you know, connect to your, you'll all kind of, you know, you'll connect to this ingress ATS at you on the left hand side, which is your on-premise network. And on the peer could be either another on-premise network or a cloud network. So SNI blind tunnel and TLS bridge more or less offer this option of, you know, securely communicating across untrusted networks. TLS bridge as such is, you know, is more or less, you know, ensures that, you know, traffic over the wire is mostly for HTTP traffic, and whereas SNI, you know, is for any RPC based traffic, that is TLS. If you see the configuration example below, you can not just configure, you can establish this bridge between multiple pairs. So if I have something called service.com, then I can say, hey, connect to my peer.ats. But if I have my FQDN matching alternate service.com, all these are regular expressions, and then connect to a different ATS server and not the same ATS server. And the advantage with TLS bridge is you can establish authentication and authorization between the ingress and peer traffic servers as well, saying that this peer ATS would not accept connections. It doesn't trust any inbound traffic server by default. Like, you know, it is based on the principles of zero trust, where you can say that only if the client certificate of the ingress ATS matches the following formats, and if you know, it is in your valid client cert authorization list, then establish the connection. If not, it would throw a 5xx error. So between the ingress and peer, there is some kind of an authentication that can be established. One more thing that I would like to talk about that we'll discuss later is something called as a proxy protocol. So proxy protocol was actually initiated and built by HA proxy. This is usually required in use cases where if your web server or an origin server is behind multiple layers of NAT or load balancers, then by default, usually you might not get the client IP address because it's the load balancer IP address that would be seen in your last hop. Now, using proxy protocol, most popular vendors support proxy protocol. So proxy protocol is this raw TCP bytes that are sent in a web communication just before the communication is initiated. So using proxy protocol, I can actually send my, so if let's say there is a load balancer, right? And there is a web server and there is a client. So once the load balancer is enabled with proxy protocol, it would send the client information that it connected to, which would be the client IP address, the destination that it wants to connect to, and the source port and the destination port. So this, and my web server should also have the ability to accept proxy protocol because it is not native HTTP. It is the first raw bytes that are sent before the communication is initiated. And then I can capture the source IP accurately of the client despite being, you know, across, you know, despite being behind a TCP proxy. Now, if you have multiple levels of TCP proxies or load balancers, then every load balancer should, like, you know, every hop should be enabled with proxy protocol so that the destination hop knows that, you know, what was the initial client that connected to it. Okay. So now we'll actually go into the use cases, right? Up until now, I was just discussing the terminologies that, you know, that are required because that would kind of help explain better what we are trying to do. So what we're trying to establish is, so we have Hadoop clusters in on-premise, And now we are expanding, we are building Hadoop clusters in cloud as well. Now we'll have this ability, we'll have a requirement for these clusters to communicate across each other. And also clients to communicate between on-prem and cloud to on-prem. And these clients should not really be worried or bothered about additional configuration to, to be required on their side to specifically connect to something that is not in their routable subnet. So actual presence of client or doesn't impact. Customers don't know that neither the customers nor the clients or servers know that it just feels to them that they're just communicating to their peer. The reason why we wanted to do this was we wanted to minimize the application level code changes that are required to establish. It could be code and configuration. And also make those reachable. So despite those subnets not being routable, still make them reachable via these traffic servers. The requirement why we had to do this was these clusters, as I said, had to communicate across each other for replication, live replication, bulk data copy, access, and running various commands, jobs, etc. So that was the requirement. And also, at the same time, be highly performant. Don't create additional latency over the wire, and end-to-end TLS encryption, so that there is no because that is a mandate. Like whenever traffic goes out of the node, it is TLS encrypted till the destination. So there were a few options. One was use something like a site-to-site VPN tunnel. Many popular cloud vendors also offer it, where there is a VPN endpoints that are established at your on-prem edge as well as at the cloud, and that would set up a virtual private network across. The concern with site-to-site VPN tunnels are they're expensive, difficult to maintain. I mean, not really. I mean, difficult to maintain is more like a complex term, and it is relative. But you need carrier-grade network devices to do this. Any cloud provider, you at least need one carrier-grade network device on your end to do this. And you also need to ensure that you don't kind of have overlapping IP addresses if you are doing RFC 1918, because you can't use the same subnet across a VPN tunnel, and then it will kind of lead to conflicts. The other option again is direct connect or cloud interconnect. Every popular cloud vendor offers this, where you can make your VPC part of, your VPC can be expanded into not just cloud, but cloud plus on-premise. At the same time, you need, it is also equally expensive. There are concerns when it goes above and beyond the scale. Like, there are limitations with bandwidth, routing table limitations, etc. So unless you are a big player, you want, cloud vendors would only listen to you based on, the amount of money that you want to shell out. Again, you might need network crypto gear at both the endpoints to kind of encrypt the traffic. External is very popular. Its on performance is also very good. But for a distributed system, any distributed system like Hadoop, etc., right, where there are multiple servers on one end and multiple servers on the other end, creating these external banks, will have, complexity issues. And also, if you are trying to do RPC that is MTLS already, then you need to kind of configure external again in similar way that it doesn't do the encryption for you, it just does a TLS pass through. So what we built here as a solution, so this is a solution that we built, is using Apache Traffic Server to establish this connectivity between our on-premise Hadoop clusters and AWS and cloud, any cloud that we have. This architecture kind of ensures that the communication is end-to-end encrypted over the wire. And, so there are like, I'll show you the architecture diagram in the next slide. And it is highly secure and scalable and cost effective in the sense that because, Yahoo has been Yahoo open sourced ATS many years ago, and then we have the in-house talent on ATS. It adheres to whatever I said earlier, like about zero trust policy. Like there is nothing like an implicit trust in place. And it is suitable for transporting both HTTP traffic and non-HTTP traffic. And it is configured as a transparent proxy. Sorry. Yeah. So what we have as an example here, so take on-premise and cloud, we have grid clusters. This grid cluster, and we have non-grid environments also. There is this ATS bank that is at the edge, and only these ATS banks can be reachable. They would have public IPs, and mhm. Mhm. Yeah, MTLS bridge actually means that you are establishing a mutual TLS between the ATS proxies. So between a client and server, it is not just server-side TLS. Client also presents its certificate. So both kind of do communicate over TLS. So you can do MTLS between client and server. It doesn't matter whether it is AWS or Azure or anything. There is nothing like that. Actually, the world is moving towards MTLS because on zero trust policy, right? All these days it is. Yeah, that is true because you would only encrypt. So you would not do MTLS between a regular client like a web browser, a regular user from my browser to a service, right? But when you are trying to communicate between two components, services or nodes, etc., there is no inherent you can't inherently or implicitly trust the other party saying that he's trying to communicate with me. Let me establish the communication. What MTLS does is, it kind of authenticates. So the server also has the ability to authenticate or verify and as well authorize the client saying that he is this unique client, and it can kind of uniquely identify one client from the other client. Every client has its own unique identity that is given, and you need not do unique identity as well, but that is the one of the core principles of doing zero trust with MTLS as well. Yeah. So the MTLS bridge, the one that you are seeing in green, is actually for HTTP traffic. The one that you see, the blue, where clusters, the clusters are communicating across the ATS proxies, even though the connection is going by the ATS bank, is the blind tunnel, the full blind tunnel. So the ATS is not terminating the connection there, right? Versus the one in green, where I connect to my proxy explicitly. There is a TLS termination. Whether how you connect to the traffic server also matters, and then that's how it works, right? Yeah. So the reason. So next we'll go about this proxy protocol. So we have this requirement of Hadoop on a given node, right? Whether it's a name node or a data node or a region server, there are multiple processes. I mean, there is one process, but it kind of spawns multiple RPC and NetT, JT web traffic servers, web servers that listen on multiple ports. So given a single node, there could be at least 4 to 5 ports that Hadoop services listen on that would be required for for the effective that would require for Hadoop to function. So one would be native RPC, the other would be for data node communication, data streamer protocol, etc. So by default, SNI configuration only allows you to so if you go by the FQDN based format, right? Given FQDN, I can only connect to a specific. So I see what is the FQDN that my client is intending to connect to, and I would route it to a port that I would define previously statically saying that, okay, web server 4443, if it's an app server, again, app server 4443, etc. But now on the same web server, let's say you are listening on multiple ports, like, 443, 80, any multiple TLS ports. And you want to connect dynamically based on not just the FQDN, but you also want to connect on additional parameters. The SNI configuration on ATS limits this ability. So here, how the proxy protocol is helping is, my client would actually connect to, I'll directly go there. Yeah. So here, my client would actually, so here is a HDFS client. It wants to connect to a HDFS name node in a different environment. But this HDFS client wouldn't know that there is a traffic server in between. It would try to resolve to this name node, which would resolve to this ATS proxy bank. And it would say, hey, I want to connect to you on this RPC port XYZ. Okay. The ATS would, okay, take this configuration. It will see that this is non-HTTP traffic. So it will do the blind tunnel, and it would communicate to its peer Apache traffic server. The peer ATS would then get the information, but now it also needs to know that the inbound port in which this client actually connected to this ATS, right? Because these are using one dedicated port. They are not using the same port that this client and the name node actually are listening on. They are using one generic port. So this client would then would connect to this ATS on a different port. This ATS should know that, okay, what port the client actually connected to on the initial. So now one way to achieve this is, use like, so let's say you have 10 ports that the name node listens on. Then open all the 10 ports between ATS, these two ATS across the internet, and just communicate, like, that is called as hop by hop port consistency, where the client connected to me on X port, I need to pass that information to my peer saying that, hey, client connected to on X, so I am also connecting to you on the same X port. You connect to the name node on the same X port. Now, from a security perspective, opening that many ports is considered critical. You don't want to do that. You don't want to expose your service, right? These are your internal services. You don't want to expose what ports you are listening on, etc., for security reasons. So here is where proxy protocol helps. So here what happens is this ATS tells these two ATS servers over proxy protocol along with the blind tunnel. This ATS tells this one, the peer, that, hey, client connected to me on this specific origin port, source port. So you connect to the name node on the same port. So let's say if I have another port here that the name node is listening and the client wants to connect to, it would connect on that second port. So as a gist, right, what proxy protocol is doing is we would only use one generic port in the blind tunnel across the ingress and peer traffic server. And there, the major advantage is that, transparent proxying approach. I am not modifying my code, neither my application, either at the client level or the service level. And it is communicating to a name node which is in the cloud, and it's not in its same network. But it is passing this information across using proxy protocol. So the ingress is configured to do proxy protocol out. The egress is configured to do proxy protocol, accept the proxy protocol in. So only the ATS servers do the proxy protocol. So the client and the servers, they don't do any kind of proxy communication. So there is no code modification there as well. So client wants to connect on port X. It connects to the ingress. The origin on port X is listening on all these ports X, Y, Z. So it connects to port X onto the ingress ATS via a generic port, and connection is established, a connection is established to the egress ATS. Then there is this blind tunnel that gets established, and this egress ATS looks the proxy protocol information headers and sees that client connected to me on port X, so I'll connect to the origin on port X. If it is port Y, then port Y, port Z, port Z. So the configuration looks like at the ingress ADS, I want to connect to some.origin.com. The route is established to egress ATS on a generic port. And at the egress ATS, the same FQDN, so the FQDN is preserved in the blind tunnel because there is no TLS termination, right? So it's a completely blind, so from an ATS perspective, the connection, the traffic is all blind. So it sees the same some.origin.com, and using the proxy protocol information, it gets the source, the port that the client actually connected to and establishes the connection. So that is the HDFS connectivity. TLS bridge can be for, one example that I gave here is a REST-based service for HBase where I can use HTTP to connect to HBase rather than connecting using RPC. So here there is a REST service that is resting in my on-premise, and similarly I have a client in the cloud. So here the client is establishing an explicit connect to the proxy, and then this proxy has this configuration saying that client connected to me and it intends to connect to this REST service, but there is a next hop defined where I have to connect to one more proxy bank. So I shouldn't do any DNS resolution or any of this sort. I just should forward this client, this connect call that I got directly to this peer ATS. So the traffic lands on the peer ATS, and then a connection is established. This is native, like regular curl call that you would use using a proxy. There is nothing new here, and there is none of the proxy protocol. All this information is a concern here because there would be only one port between the traffic servers, and we are not doing any SNI kind of blind tunneling here. So you can use any ports between on the REST service and the client. It all depends on how you configure your FQDNs. Right. So for the whole setup to work, right, the whole setup is working on explicit proxying, where my client in on-premise, if it wants to connect to services in the cloud, all the DNS records for my services in the cloud would actually resolve to my traffic server. They would not directly resolve to the actual destination. So using a wildcard CNAME record, I can kind of, and something called as a DNS zone splitting, where I can say that if you are connecting from a small private subnet in one network, all records will resolve to this cloud proxy VIP bank or a load balancer bank. So it would it will always try to connect to this Apache Traffic Server Cloud Proxy, thinking that it is the origin. So once the ATS gets the connection, it verifies the SNI header information about in the client hello. It establishes those routing rules by verifying the configuration and establishes the connection. So we have regex rules because we have like 50,000 hosts, so we can't create root entries for every host. So regex rules help, like whatever I showed you, like star.origin.com. That means that anything under origin.com, apply this rule. And everything is strict MTLS in the case of HTTP traffic. And it is not just HTTP, but RPC as well. And we have network ACLs to count, for additional security. So that's about the cloud proxy. Quickly, we'll go through auth proxy as well. So auth proxy is where we had this requirement of establishing OAuth, OIDC, and there are a few constraints. One constraint is every node in the grid required public internet connectivity to verify the OAuth tokens. Now, the way OAuth works is you would have a client secret that is required before you actually establish the auth. And sharing one client secret across all of your nodes is also not considered secure. And the complexity involved, like within Hadoop umbrella, right? There are multiple multiple applications that are designed differently. So making code changes at every application to enable OIDC connectivity is also very complex. Now, in this case, how a traffic server helps is, in this case, how a traffic server helps is it keeps your authentication footprint small. So there would be a dedicated bank of servers that are assigned to do this job of authenticate the user. And you don't really make major code changes at every application level. You would trust on this traffic server to do the authentication for you. And you would kind of keep, so it kind of keeps the authentication footprint small. And you don't, you will kind of keep the application, you won't burden your application. You would decouple it. And you would also have the advantage of shifting from one OAuth provider to another OAuth provider, keep it very simple, because, if you're trying to shift from, let's say, Okta to someone else, then you would just make code changes at the proxy layer and not worry about, touching all Hadoop applications. And the other major advantage that you could get is, if you buy SSL certificates from any popular vendor, the TLS termination happens at the traffic server level. And you don't need to put all these SSL certificates across all of your hosts, because there you would do some kind of MTLS between the auth proxy and the servers. You would only use the commercial certificates on your edge, the auth proxy servers. So this is also another kind of explicit proxying, transparent proxying, where the client, so you can do it using explicit proxying also, where you would ask, you would set up every browser with a proxy configuration file saying that if this is the domain, go through a proxy. The other approach is, as I said, this transparent proxying, where at the router layer, if you have network routers, any popular routers can do this based on the destination that you are trying to connect to. So here is my destination that I'm connecting to a Hadoop service, and I could so this is my regular traffic. So I'm going like this, but I would establish this transparent proxying in such a way that don't do the direct route. Packets destined to this would actually, so the router changes the next hop, and you would require some kind of IP tables rules also here. So the traffic, instead of directly going here, will go through this proxy bank of yours. This would enforce all the requisite OIDC, OAuth, what is required, and then route it to this service. So you would actually have one more step here to kind of verify that is the authentication happened or not, etc. So this is more or less one of the very popular examples of transparent proxying, where you need a router. The router is actually changing the next hop and enforces whatever you want. Here in our example, we are trying to do authentication. So a regular OIDC OAuth flow, a client wants to connect to a protected resource server. The traffic actually lands on the proxy because the router routed it there. It would look for valid access tokens, or in the case of Okta, it is Okta access tokens. And if those are not present, it would redirect you to your identity provider, and you would authenticate. It would also pass the client secret and the client credentials. It would authenticate and send you the authorization grant, and which will be the callback URL, which will be the same as your proxy service. And once you kind of complete and you have a valid token, then the connection is relayed to the actual destination or the resource server that you want to protect to. So if it is invalid, if there is no token, then you would get a 401 error if you're trying to, if you're doing anything that is not accepted by the proxy. So that completes my presentation. If you have any questions or any of those sorts.
MTLS. Or what is the use case like? Generally, if we have got a browser, you told like when we connect first time, we does not need to do SSL certification. Then what are the scenario we can use that, and which is the best use case for that?
So MTLS is where you uniquely want to identify a client. I mean, it's not really that use case. MTLS is secure over server-side TLS because here, in the case of server-side TLS, it is only the server that is establishing the TLS encryption. In the case of MTLS, it is not just the server, but both the server and client that do TLS between each other. So it is considered secure, that is by default. But the main advantage that you are getting is you have the ability to uniquely identify and authorize every client. Now you don't want to, usually MTLS use cases are not with regular real users, right? Real users, like, if I'm trying to communicate with a web service, with a UI, I don't usually select a certificate. I mean, there are some secure sites that do that. It is only between services, whether it is, whether you go for Kubernetes-based services, or within your data center, you don't want to establish this explicit trust. You want to validate that this client is actually the client that you want to communicate to, and it also has it is also authorized to be part of your communication. That's where MTLS gives you the advantage.
Thank you.
Any other question? Cool. If no question, yeah, we can head over to lunch. We'll have a 30-minute lunch break because our initial time was spent. We'll resume at 2 p.m. Please.
Hello.
Hello. Hello. Okay, so we are gearing back. I'm pretty much sure that Vineet is being bumped up with question, and Rishabh has taken in a corner place so that Rishabh doesn't have to face question during the break. Okay, so is Sharmila talk is back? Sharmila? Will come, right? Okay, so while you settle back to your seats, generally this session post lunch, keeping people awake is a different skill. Okay, I don't know whether our current speakers are all good. You know how to keep people awake? Good, best. So okay, so we'll wait for a moment. I will get Sharmila to introduce the speakers for the second hub. I think Sharmila is getting back. Till that time, please settle down to your chairs and request you to take the first rows. Otherwise, I'll remove the first row. But if I remove the first row, the second becomes first. That's a challenge. Sharmila. So I'll take the privilege to introduce you to, at LSP leadership level, LSP rather, there is no leadership. There are a bunch of organizers who are like-minded. Anshu, you still there? Okay, maybe it's Singapore evening time, post-evening. So at LSP organizer level, we have a diversity crisis. Okay, there is no diversity. It's all like me, Anil and stuff. So Sharmila volunteered to become our diversity member in the organizers group. So I never hesitated. Means the moment I saw Sharmila in WhatsApp saying that, would you like to get me to this organizer forum? I said, well, you have come to the next event. So to introduce you to Sharmila, Sharmila runs a YouTube channel called Sharmila Talkies. You will see many of us ranting in her channel. She gives us privileges at different point in time. Over to Sharmila to talk about her a bit and then introduce the second of speakers.
Thanks, Divanshu. That was a lot. Hey, good afternoon, everybody. So I'm Sharmila. I have about 20 years of experience in the IT world. I worked with companies like Dell, Yahoo, Intuit, LogMe, and I currently work for a fintech Indian-based startup called Open Financial Technologies. And I'm based out of Bangalore. That's enough. So moving on to the next person, that's the SRE team from Myntra. They're going to talk about, you must have seen, it's about Kubernetes and VM monitoring. So we had in a couple of sessions previously did emphasize the need on monitoring. So they're going to talk about how they deal with the monitoring at Myntra for the scale of traffic that they actually go ahead and deal day in or day out. So over to you guys.
Okay, so everyone has settled down, I guess. Hope we can start. Okay. Yeah. So, like, we'll get started. Hi, everyone. I am Sumit from Myntra. Previously, I worked with Ola, Bounce as well. And I'm part of SRE team right now in Myntra.
Yeah, hi guys. I'm Sairam. I work in Myntra in SRE team. In Myntra SRE team, we manage all the infrastructure, which includes like large-scale Kubernetes clusters, observability, monitoring, logging, security, and obviously like fighting production issues. Today in this session, we are going to talk about the monitoring session we have at scale. Yeah. Yeah. Before starting, right, we want to know like. Go inside. Okay, the camera. Yeah. Before we start the session, right, just want to know how many people are using Kubernetes in production? Oh. Yeah. Good number. Now, how many people are using Prometheus in production? Okay. Yeah.
Yeah. So, have you heard about Thanos as well? Okay. Anyone using it in production right now? Okay.
Okay. There is one hand like which says like Thanos they're using in production. We are two.
Yeah.
So yeah, today's discussion will around the journey we faced with the journey we had with monitoring, how we started from typical Prometheus monitoring system, and then how we evolved to scale, like how we make our system suitable for scale using Thanos.
So as we are here in large-scale production engineering meetup, we'll start with the scale for monitoring which we operate in as of now in Myntra. Then we'll have a quick refresher for Prometheus. It seems like overall, like we have an audience who can understand Prometheus and maybe a little bit of Thanos as well. But again, the next is our like as we are starting with Prometheus, right? What was our journey and how we learned about different things about our Prometheus, Thanos, and all the challenges, how we got, and then how we proceed further to solving them, right? And we'll just quickly do a recap and then talk about the final architecture as well. Okay. So getting started with scale. So as of now, right, we have multiple clusters running in Myntra in terms of VMs, in terms of Kubernetes, right? We have different targets. So as of now, it looks like we have around 23,000 targets, which consist of pods, containers, virtual machines, and in terms of samples which we scrape per second, right? Overall, we had a review on that, and then we found out like we are at 4 million samples scrapes per second as of now. Which is across multiple clusters. We are having right now hot storage of like for 7 days, which we give from the disk, right? That is around 18 TB right now. And as of now, for the read queries, right, we have been seeing on an average 140 query per second, which is like our users using it through Grafana or directly through Prometheus UIs. In terms of latency for the read, we have seen max P99 at around 8 seconds, sorry, and average P99 of 200 milliseconds. Okay. So when you talk about Prometheus, right, it's a I think everyone knows about it, that it has a very vast community in open source, and almost everyone uses this in current scenario, I think. So it provides us multi-dimensional data model. Basically, what it does for us is, like with a single metric, right, we can actually plot different kinds of dashboards, right? Because it comes with a labels, which is basically a key value pairs. Using them, you can write different kind of queries, sort based on that, and then, like, I will take an example of HTTP count, right, which is basically showing you the count of request. Like maybe it can be per minute or per second. Whereas it can have another label, which is status code, simple, right, which is giving you the status code of the response for that request count. So you can use the same metric to plot two different things, that is the status codes and the RPMs. Now, Prometheus comes with this Prometheus query language, which is very simple to understand. You get multiple functions along with it to do calculate different kind of things, right? And it's having its own database, which is open time series database. It stores data all in local storage as of now, and it works as a pool model over which basically scrapes the metrics through HTTP request, right? And targets, the targets in this case are like pods or VMs, containers, which can be discovered by multiple ways in Prometheus. One way is like a service discovery, which natively comes from Prometheus. It supports Kubernetes service discovery, like various cloud providers based service discovery, or a static or a file based service discovery. And there are very multiple modes of graphing and dashboarding, right? Like you can you can get multiple in, we can say something about multiple modes of transport, right? Multi-mode of graphing way.
Yeah, we can have like Grafana, Prometheus UI, multiple different ways of dashboarding.
And along with that, right, there are like different other Prometheus, sorry, the computations to Prometheus, right? Like StatsD or different kinds of open source technologies. But Prometheus mostly works with the pool based, and it basically has to be configured on the Prometheus configuration, and you basically scrape what you want, right, on the targets. Like StatsD has a push based, where you don't maybe have a control over how much amount of data is being pushed, right? And quickly, we'll go through these architectural diagrams. Prometheus is a single node architecture, which comes with like a single, inside a single VM, it has a database as well. It has all the scraping related logic as well, right? And it also can actually, it has a push gateway model also, where actually any application can push the data to a push gateway. However, from push gateway, Prometheus is actually going to pull the data. So time, like the data will be stored in push gateway, which will have some storage, and then Prometheus, once it scrapes, it will store the Prometheus on its own data. Right, and multiple UIs, like we said, right? We have Prometheus UI, which natively comes. Grafana is one of the major open source dashboarding platform which we use. And there are different API clients, API which Prometheus provides, which you can use. Okay, so now had in terms of monitoring, what we wanted, like when we started, right, was because we had multiple different Kubernetes clusters, maybe more than 10 clusters in terms of Kubernetes, a lot of different virtual machines for stateful sets and all. We had to have a different Prometheus setups basically to monitor each test, right? So in that case, we also wanted to have one querier, one global view, like one Grafana and one single view from where you can actually scrape all kind of metrics, or basically view all kind of metrics. And we wanted to have we had a requirement like if we can get like 7 days of data in the hot storage, which will be very, very fast in terms of in panels, like loading in panels. And we could have like some kind of long-term storage plan where we can have cold storage, which can be loaded by the dashboard itself. And we are trying to look at the old metrics, right? So typically, this kind of design would come in your picture, right? We have multiple data stores, data sources of Prometheus, maybe queried by single Grafana, right? And you will have different panels for each data source, because you cannot combine single data source for multiple queries, right? Now, another thing, like one of the major challenge is a global view in terms of Prometheus. When you have multiple clusters set up, the aggregation of data, especially, right, across the clusters, like let's say you have a global, like 10 clusters, you want to find out what is the total resource usage or total CPU usage allocated, I can say, or allocated across the clusters, right? Overall, you can get the data with a single query, basically, right? That kind of requirement we had, and like there's obviously some federation available, right, from Prometheus natively, which comes with a separate Prometheus actually, which again queries another Prometheus, and that comes as a bottleneck, right? So that has to be monitored. That HA has to be there, right? And the maintenance of that, right, will be okay. Now, like in terms of availability, right? As you know, I said Prometheus is a single node architecture. In terms of replica, HA also, what we do normally is we add another Prometheus replica which has a similar configuration, which is basically scraping the same kind of data, right? Maybe the scrape timings are a little bit different, but it's kind of scraping similar data, and you are just load balancing both of those replicas, right? But still, like one of the Prometheus is down, one of the Prometheus server is down, let's say, and when the request goes from one of the load balancer to that Prometheus, because maybe like for a certain period it was down, but it came up, let's say. Now load balancer is sending the request to that Prometheus, but that Prometheus doesn't have that data for the time which was down, right? Now, what you'll, as an end user, you'll see a blank gaps in your panels, right? Dashboard panels. That will still happen. So that's a challenge for high availability. And in terms of deduplications, basically, when you have a query, in terms of rules, basically, rules and alertings, where do you want to set the alerting, right? You want to set it up only on 1 or 2, because you will end up getting 2 alerts maybe, right? That's a challenge there. So another challenge is long-term retention. Now, you can think of maybe having like last 7 days of data on the disk, but as you saw, our requirement and our use case as of now, which goes to 18 TB for 7 days only. If 7 days of data we can store in disk still, which is SSD disk. However, it comes with a cost, right? And if you want to have a backup or just like have 2 replicas, that's already there. Now, it still again comes with more number of like challenges, because we have already been seen there are numerous other open source tools available in the market which are solving different kind of Prometheus problems, basically. So another problem is no downsampling, right? So when you want to query the very old data, let's say it is 30 days old data, and if you are querying from Prometheus, what it does is it's kind of real-time querying, right? It checks what was the data there, and it has to give you the data. But let's say you were scraping at 15 seconds interval, you will have a granularity of 15 seconds in terms of data. However, if you had, let's say, some kind of downsampling, which could actually compact the data, just reduce the granularity for that data, and basically reduce the disk and the and the query time, right? It would be very helpful. That's what we thought. And another thing is caching. Like I said, again, it's a real-time query. Every time going to Prometheus disk and getting that data. So multiple users trying to query the same data actually goes and does the same thing, and then it ends up using more memory in that case, right? Like another, that horizontal scaling is always a problem because you can have multiple replicas, but still you end up losing some kind of data in terms of maybe during some maintenance or certain scenarios like automaticity or something like that, right? Okay, so these are the challenges. We'll just have a quick recap on the challenges which we had. The global view, right? That is something like you have one single data source which can give you the data which can be aggregated across the clusters. HA, the HA is like something we wanted to have in Prometheus. So we had found some solution for this, which actually can go and solve different HA availability problems, right? And it's not just about that, like long-term storage we can have different data stores, right? Maybe like we can use object storage, right? That is one of the solution which you can maybe see we have. And caching, right? The caching was the problem because Prometheus doesn't come with the native caching. Yeah, so I think mostly I've covered the challenges what we have had in terms of a normal journey in setting up Prometheus and scaling it up to the scale that we have right now. So there were different solutions in the market, right? But we thought of choosing something. Maybe we did multiple POCs on different things. Sai will help understanding all those technologies which we have maybe tried and what we ended up using and which helped us solving these challenges.
Yeah, before I start how Myntra solved these challenges or like how Thanos is helping us, maybe like these challenges are quite common if you are having scale and using Prometheus. Maybe you can tell like how your organization or how you're trying to solve it. Anyone? Okay, at least then I'll start like how Myntra started. So I think enough of the problems. So we use Thanos. So Thanos is a open source, highly available Prometheus setup with long-term storage capabilities. Like the main philosophy of Thanos is not to reinvent the wheel. So they're trying to use best of Prometheus as much as it can and improve its shortcomings. So it has minimal number of dependencies. So it has like few components. Some components will be running along with Prometheus. Some components will be running as a service on its own, which will help make our monitoring system more efficient. It has very minimal baseline cost. The CPU memory disk utilization of it is very less. It has seamless integration with Prometheus. It supports Prometheus API by default. So if your queries are already in PromQL, you can use the same queries on top of Thanos Querier as well. They'll work right away. Even in Grafana, when you add Thanos as an integration, you have to choose Prometheus only. And deployment model is quite easy. If you are into Kubernetes, it's even more easy. It has like multiple components like a Thanos sidecar, Thanos store, Thanos querier, query frontend, and compactor. There are a few more components as well, like ruler and receiver and all. So, but at least in Myntra, we are not using them yet. So I didn't mention in the slide. So this is the basic architecture. Like historically, the normal architecture would be like Grafana directly querying to Prometheus. With addition of Thanos, we would be including a Thanos query frontend, querier, Thanos sidecar, and then Prometheus. So that would be the flow of the query. Okay, we'd be discussing each component while we solve the challenges we mentioned before. Global view. So we discussed like we'll not be having a global view when we reach a scale because we have like multiple different Prometheus running. The way Thanos solves it is like by adding one additional component called Thanos sidecar. So Thanos sidecar is the component which runs along with every Prometheus. It has access to Prometheus data directory, and it implements a store API. Means every component in Thanos implements store API. Maybe let me explain you what store API is first. It has like kind of 4 methods, like info, series, label names, and values. So info is the method which will be called by querier in an interval like 10 seconds. It acts like a health check. At the same time, the response from info is, since Thanos Sidecar has access to the data directory, it's going to see like what all metrics are available in that Prometheus. And it's going to give that data back to querier. So that when we make a query on Thanos querier, it's not going to fan out to all the Prometheus at once. Already Thanos Sidecar mentioned like that Prometheus has these particular metrics. So if that particular metrics are means like if you're querying a metric and it's not available in that particular Prometheus, Thanos querier will not fan out query to that particular Prometheus. So that's like main function of Sidecar to ensure like query goes to right place. Along with series. Series is the API where Thanos Sidecar gives data back to querier. Label names and values, that's used for autofill. So when you try to type a query and you type a label, right, you get automatic suggestions. So for that, it's using label names and label values. So that's regarding Sidecar. And then Thanos querier. Thanos querier is capable of querying from multiple data sources, merge the data, and provide result back to Grafana. So now we can understand, right? By using info API, Thanos querier knows like what metric is present in what Prometheus. And it uses series API to get the data. And then there is like merging and deduplication logic in Thanos querier. It does all that and gives back to Grafana. So next thing is like how we solve availability. Like previously we had like 2 parallel replicas of Prometheus, and one went down for some time and came back up again. So that time, if you have single Prometheus, your data is lost. If you have like multiple Prometheus and having a load balancer on top, whenever query goes to that Prometheus which went down, we are going to see that empty graph. Where how Thanos querier comes into picture is Thanos querier queries from both Prometheus, gets the data, and it merges, deduplicates, and gives back to querier. Yeah, we may think here, right, like why to have same metric, why to scrape same metric from 2 different places? Like it's like effectively increasing 100% of the data and increasing resources, like doubling everything. But replica 1, right, it's gonna, like let's say we have a job which scrape interval is 30 seconds. First replica is gonna scrape at like 0 and 30, and second replica is gonna scrape at like 15 and 45. Like that difference is there. So at the end, right, the overall data accuracy will improve. If we want, we can increase data scrape interval also, because like anyway we have data in 2 places and Thanos querier is taking care of merging and duplication. That way we have data which is more accurate, and we can think of reduction of size and resources as well. Yeah, so that's how Thanos querier is helping with availability. Okay, long-term storage. Previously, right, we have data only in SSD. And we used to see like we have a scale of like we are using 18 TB data for a week. So if we want to have like 45 days retention, like that, if you use typical Prometheus system, that SSD has to be like some 70 TB or something, which is like not practical. So Thanos leverages object storage for this. So normally Prometheus stores data in TSDB blocks. Every block will have like min time, maximum time, metadata, like what all metrics are available in it. So we have already one component called Thanos Sidecar running along with Prometheus. So Thanos Sidecar, what it's going to do is like whenever a new block is created, based on the config we give, it can upload into a particular object storage. Like all major object storage like Blob, S3, Google Cloud Storage, all are supported. It's going to upload. And then to query the data, we have another component called Thanos Store. So what in Thanos Store, again, we'll give the config of the blob or like any object storage we use. What it does is, whenever store is starting for the first time, it's going to download all metadata files, which are already present in TSDB block. and it's going to make one index file out of it. Like if you're making some query, it's going to know, like based on, we already have min time, max time, and the metric names in the metadata. So based on that, it's going to choose like which blob it has to query from. And it'll try to optimize it. So that data is present in index file. It uses that to query blob and gives back the results. And store also is implemented. Store API is also implemented in store. So that way, like Thanos querier will hit the store and get the data and gives back to Prometheus. Again, same deduplication and merging logic is applied here. So in the picture, you can see like the sidecar is uploading TSDB block to object storage. And we have querier connecting to store using store API and store getting data from object storage. OK, so this is downsampling. So now, if you see, right, we have like jobs which are scraping at like 15-second interval, 30-second interval, and users plotting data for like 7 days graph. So in that way, what's going to happen is like we have like more data points than the pixels which are present in the screen. And normally when we use Prometheus, like Grafana will add a step parameter and gives that to Prometheus. So that way what's going to happen is like Prometheus is not giving all the data points. It uses step interval and it selects certain data points and gives based on that. Whereas when we come to Thanos store, right, problem is it cannot do that. What it has to do is like it has to download all the data from the blob, then compress it using the step param and send back. So here we are like querying huge amount of data, which is not necessary. And then again, we have to decompress the data. So that's also going to take time, right? So we have to downsample data. So Thanos comes with another component called Thanos compactor. What it does is it takes the raw data and it makes like 5-minute and 1-hour blocks. So let's say there is like one metric, something is there like for 5 minutes. It's going to calculate, compress it, and it's going to keep minimum, maximum, sum, count, and counter. It's going to use that, like let's say a rate query came. So it's going to use that counter aggregation, and it's going to use that for rate. Let's say average came. So it's going to use sum and count, which are like decompressed, which are compressed, and it's going to plot the graph. So all these 5 are like sufficient to handle all functions Prometheus supports. And yeah, now we have like 5-minute compressed blocks in blob, 1-hour compressed blocks in blob. So when you have a query where step param is more than 5 minutes, Thanos store is smart enough to query 5-minute blocks. If that step param is more than 1 hour, Thanos store will query that 1-hour block. So instead of like fetching all raw data, compress it, and giving back, it's going to get less data and give it back to user. So, and in Grafana, like that step interval is automatically calculated by time range and max data points it can plot in a screen. Along with compression, right? Thanos compactor also takes care of deleting metrics from blob after retention period. Like we don't want to have metrics for like forever, right? Maybe like 1 year is sufficient for some people, like 45 days is sufficient for our use case. So after that period, Thanos compactor will delete that data from the blob. Next thing is caching. This is interesting. So normally when we have dashboards, right, in Grafana, we have like refresh, auto refresh enabled, right? Some 5 seconds or something. What we have observed is a lot of users just keep the graph in the browser and leave it. And we are getting like so much extra load. And every time we get that extra load, Thanos querier is going to send to every Prometheus, and that query is happening. And we don't have any caching mechanism in between. So Thanos comes with another component called Thanos query frontend. It takes care of caching. Like so what it does is, let's say you're querying like 7 days query. First, it's going to split that into like multiple, we can give that interval, like multiple 1-hour queries or 2-hour queries, something. And it queries, it gets the data from it. Thanos query frontend will call Thanos querier, which will query like fan out query across all Prometheus, get the data, and then Thanos query frontend is going to cache it in memory. Like there are like different kinds of systems supported. It can cache that in memcache, Redis, in memory, like that. So it's going to cache it and gives back to Grafana. And next time, if same query comes, whatever is present in the cache, it's going to use that. Whatever is left, means remaining, which is not there in the cache, it's going to query Prometheus and give it back. So that way, like, I think this component, right, particularly helped us to decrease our average P99 latencies of query. So it was quite helpful in our case. And then sharding, like normally, like Prometheus is only scalable vertically. And we have certain services where like, which is running with like 400, means like during the EORS events, we'll be running with like hundreds of pods. So even if we try to do like functional sharding where like you have like one service metrics in one Prometheus, it's not helping us. And then if you do that, right, service specific Prometheus, then managing each Prometheus is like, again, a big task. Like we have to scale them independently, all those things were there. So we started using Prometheus operator in Kubernetes. Actually, like we were using Prometheus operator from long time, but we started using sharding feature in it. So if you see, right, we are scraping 4 million metrics per second. So without automatic sharding, it's quite hard for us to do functional, means it's quite hard for us to do only functional sharding. So it's like, I think maybe I'll give a brief intro about Prometheus operator. So normally when we use Prometheus in Kubernetes, we use with stateful set, PVC, that single Prometheus. But when you have to upload, when you have to change the config, you have to manually edit that Prometheus YAML config map, and you have to hit a reload curl. That is like, and when you have like multiple users working on it, right? Like if there are like multiple changes in a day, it's quite hard. Like when you have like, how much? Like 27K targets, we'll be having lot of jobs for them. Like, and managing each job in one config file is very hard manually. So this Prometheus operator gives us like different kinds of CRDs. So we have certain CRDs called service monitor, where you can provide scraping config based on Kubernetes selectors. It provides Prometheus rules, where you can add automatic alert rules. So those are CRDs. So user can create a CRD directly, like of Prometheus rule or service monitor. And Prometheus operator is going to take care of converting it into Prometheus config file, and it automatically reloads Prometheus. So that way, like management of huge number of rules are converted into like managing CRDs, which are like independent. And it provides sharding feature also. It kind of uses this particular config where it takes the address and applies mod function of like total number of shards. This is a screenshot of a Prometheus setup, which is using 9 shards. So it takes the address and it does modulus of 9 and has the result in temp hash. And if the temp hash is matching to that particular shard value, right, it's going to keep in that shard. Other targets, it's going to drop. So it can be done in VM Prometheus as well. It's easy config. Yeah, this is our final architecture with one cluster. So when you load a dashboard, it's going to query Thanos query frontend. If that metrics are already cached, it's going to give you the result back. If metrics are not present in the cache, it's going to forward to querier. Querier has intelligence of which shard to query, which Prometheus to query. Worst case, if our query is very bad, it's going to fan out that query to all. Like there's a use case, let's say like a particular metric is present in all the Prometheus. So in that case, it's going to ask all Prometheus, and it's going to get the data back. That query is also going to sidecar, and sidecar is contacting Prometheus. It's also going to store, which is checking historical data, which is there in object storage. And it's getting back to querier. Querier is giving back to query frontend, and it's giving back to Grafana. This is full architecture with multiple Kubernetes clusters. So one of the requirement we had was we wanted to have like single endpoint to query everything. Because like our services, some services are running in multiple clusters. If they want to see like total RPM of a service, right, that query has to go to different Prometheus which are present in different clusters. So like that, we are using single querier setup, which will contact Prometheus of all clusters. and gives back data to query frontend. And both query frontend and Thanos query are horizontally scalable. That is not depicted in the picture. So you can have like multiple Thanos queries. And Thanos query frontend is horizontally scalable. If you're using in-memory caching with Thanos query frontend, like each cache is going to be independent. So in that case, right, you can use Redis as caching mechanism and horizontally scale Thanos query frontend, so that always that cache will be picked from Redis, and user can see data back in Grafana. Okay. And like Sumit started, like our journey is still in progress. So we are still thinking to make a lot of improvements in our monitoring system. First thing is cross-shard recording rules. So one I think use case which everyone would have observed is like if kubelet gives us some metrics, kubestate metrics give us some metrics. So kubestate metrics has certain metrics where we know like pod label, etc. Here we have CPU metric. So we want to have certain metrics which has like CPU with pod labels, etc. So in that case, right, we normally people use recording rules where we take two metrics, compute something, and keep it as a final one metric. So if data is present in single shard or like single Prometheus, right, we can do that. But because of the scaling, we did all the sharding, everything. What's happening is like kubelet metric is present in one shard, kubestate metrics is present in another shard. So that way certain recording rules are failing. So for now, what we did is we scaled up and we are ensuring like kubestate metrics is present in every shard. But we are trying to find some proper solution for it. And then Thanos store sharding and partitioning. I think like when we worked on monitoring, right, I think like majority of time we spent, I think like not majority, I'd say, good amount of time we spent in optimizations regarding to Thanos store. Because since it is getting data from object storage, right, it's slow a bit. Yeah, so we want to implement, right now we have implemented time-based partitioning where we have like min time and max time config in Thanos store. If it is like data from today to last 7 days, it goes to one store. 7 days to older, it goes to one store, something like that. That we want to improve to some index-based partitioning and then auto-scaling. So whenever our sale events happen, right, we scale up and then we suddenly start seeing a lot of metrics. And sometimes those scale-ups happen without our notice as well. So in that case, like commonly we see is like Prometheus is reaching its peak memory and it's going out of memory and it's continuously restarting. So and maybe like we have some alerts with respect to the thresholds we have and we manually scale. We want to achieve auto scaling in some way. Since it's operated from Prometheus operator and then stateful sets are involved, it's becoming quite tricky for us to implement auto scaling that we are figuring out. And then limiting samples per target. I think this is pretty basic, but we didn't do, where targets are increased and developers made some new implementations. Today that certain pods were giving us like some 1,000 samples in a scrape. Suddenly they're giving 5,000. So, and if it's happened for globally, right, our monitoring system, we don't see increase in targets, but we are going to crash. So we did not implement it like this. We are working very closely with developers to figure out the right threshold and kept those policies. Yeah, feel free to ask questions. You mean, okay.
Like Mike, what do you mean by cross-siding? Like when I got different clusters in the Kubernetes and different containers, then how does it work cross-siding?
I mean cross-shard recording rules. So where, like even in a single or like multiple, you can take different Prometheus and different clusters. You have like two different metrics present in two different shards, and you want to have a recording rule where you compute something like you take both and create one new metric, but those two source metrics are present in different shards. So that we are not able to achieve easily. So that we want to figure out some way.
Hi, I have two questions.
Yeah.
How are you doing monitoring of your monitoring, like how you're monitoring your monitoring system?
Yep.
And second thing, it's sometime back I worked on Prometheus, I don't remember, but you did mention replication in Prometheus. How
Okay.
does that work?
Okay, okay, yeah, I'll tell. So we have, okay, this is not changed. So here, if you see, right, we have like different Prometheus setup here. So we did some kind of functional sharding like app Prometheus, system Prometheus, ingress, and linkerd Prometheus. So we have understood like by splitting them in this way, we can like have some balance. So app Prometheus is managed by, app Prometheus is getting monitored by system Prometheus is getting monitored by linkerd. Like that, we have like that kind of like one Prometheus system is monitoring another. And if not this, right, we can have like one Prometheus which is monitoring all other Prometheus as well. And then second question, when we mean replication, right, it's not Prometheus to Prometheus replication. We have like two different Prometheus having same config, scraping same set of targets. Okay, that way we are duplicating data. But I mentioned, right, first Prometheus might be scraping at 0th and 15th second. Second Prometheus would be scraping at like 10th and 20th second. That way we are, means like naturally data is not exactly duplicate. We are finding that. Yeah. Normally, like we can use Prometheus Federation or some kind of remote write APIs. But yeah, Federation, right? If you have like one federated Prometheus and have multiple Prometheus, so I think at least like with the scale we are handling, right? Federation is not going to solve our problem because like it's so many. But Federation is like a good solution for some certain use cases. And then there is remote write API where people use it like different use cases, like they scrape from Prometheus and remote write to Influx and query from Influx, or like they write in some other Victoria metrics, or like there are like multiple use cases like which people can use.
Thanks.
Yeah.
Ashish, additionally, right, when you said sharding right here, where is that? When you say sharding, like you have multiple Prometheus, right? The targets which are there, right, are like hashed.
Yeah.
Like they are. It's not that one shard will scrape the same end targets. They are every time, like whenever there is a change in target, it is hashed and distributed across the shards and replicas all the time. So that way, that scaling part is taken care of.
Yeah, we can see the config, like how that hashing is happening here. So like,
There's a limit to post scale vertically. And here we have a benchmark of Prometheus scaling, I think 8,000 metrics per second. But that is, again, follow me. With this operator is actually solved.
and then after doing horizontal scaling without Thanos query, we cannot aggregate the data. So the moment you do horizontal scaling, you need Thanos query.
Like here, can you highlight on like, can you create dashboards like for different type of metrics, like basically on the Grafana, or like so like how that is like is the queries are slower basically if you do joins and like have the basically.
So normally, like when you have a dashboard, right, query is stored in Grafana itself. And we are going to use like Thanos query, right, that endpoint in Grafana. And data source type would be Prometheus. Like Thanos query is compatible, Thanos query frontend and query, both are like compatible with Prometheus PromQL API. So query is stored in Grafana, and when Grafana queries, like you mean like you said like cross-join queries, right? Those can be added in Grafana, and it's like same flow, like query is going to get data from Prometheus and give it back somewhere.
Looks like you had a lot of bottlenecks using Prometheus monitoring in your infrastructure. Was there an attempt to consider other monitoring tools other than Prometheus, which tackles the problems that you faced in solving those issues here?
Okay, good question. So when we started, right, we have like stats in place, and already like Kubernetes comes with support to Prometheus, right? Like kubelet gives metrics in Prometheus, kubelet exposes metric in Prometheus format. So we started with Prometheus itself, and we were using Thanos for it. And yeah, lately like we are doing, and then we evaluated Cortex as well. So, you know, right, Cortex is like all push-based and Thanos is pull-based. Like both are working in sync. Like right now, both teams, right, they're working closely with each other and trying to take best out of each other. Like best feature in Cortex, like the query front end, it used to be in Cortex. They took that mechanism, implemented as Thanos query front end. Like that it was happening. So that time we felt like pull-based mechanism would be better for our organization, and we chose Thanos. And lately we are doing, means we are considering POCs of Victoria metrics and other things as well. It's still in progress. Srini. Prometheus.
See, like you said, no, like first reason is Kubernetes provides Prometheus metrics for us out of the box, and it's available for me to use it. So I'll pull that. Now, only problem is pulling is not a problem. How do you store it and how do you retrieve it? That storage part is what we are, you know, like you said, Victoria metrics is one of them which we are considering. We'll have to see how, because this is distributed. The data currently is stored in each of the Prometheus shards. So each shard is actually a Prometheus instance, and data is local to that particular shard. It's kind of like a distributed, data is distributed across multiple shards. When you put in Victoria metrics, we get in, though it is distributed there, but at least it's in a one single, you know, it is like, yeah. And it's, of course, it's TSDB kind of, but Victoria metrics has done a lot of optimizations and storage and query and all that. Yes, so only the storage part we might think to change it, but otherwise the way how it works here is pretty good. See, one thing is not covered here is how is Myntra, you know, is connected to the system or interface with the system. Like he said, right? The system is just, it's not just Kubernetes. We monitor even VMs here. So how do you inject VMs here? So that means we should have our own inventory system from where we pull our, you know, put our VMs there as targets and push into the system there. So there's one more, you know, Myntra things, like, you know, it's a general thing. It's different for each of them. They'll have their own inventory system. You take that, you compile a set of targets which has to get into monitoring, and it goes into the same system. So this is not just for Kubernetes, though the system is running in Kubernetes, but this is used to scrape you on the external VMs also. Right. So we don't want to change all that. What would change in future is just probably the way how we store, and probably give them a faster query, because the cardinality and all is pretty high here. And currently Prometheus, even when sharding, there is a, you know, there's a cost also coming in. So that we have to consider, that's why.
And then, right, one thing I can say. So here, right, whenever you see out of memory issues, right, what's going to happen is like some, like let's say like in our Prometheus, shard 10 may fail with out of memory. But with the Thanos in place, right, during those kind of issues or something, still Thanos Courier is getting data from all other shards or all other Prometheus which are live and giving us partial data, which is helpful in certain use cases. So if something happens, right, maybe one Prometheus will break, but other Prometheus which has like RPM data can give us and help us. And if we use some like Victoria metrics or something, means like any other monitoring tool, still we have to use Prometheus to scrape metrics from kubelet and everything, and then we have to push it to that endpoint, be it like stats3 endpoint or something. Still, like Prometheus will be in place, we have to find something. And given Prometheus is like proper, like it's like graduated in CNCF. Thanos is also graduated in CNCF. With this much community support and CNCF support, right? I think this is decent solution. Yeah, we can do this. But that is quite challenging. With Prometheus, like we have YAML files everywhere. So we added Thanos sidecar as like one image, and we use the common storage. We'll mount it to both containers, and we are sorted. Whereas if you have to do it in VMs, you have to write really good Ansible playbooks or Chef, anything we use. But it's totally supported in VMs as well.
Any more question? Cool.
Yep.
If no, we will take to next.
Thank you, guys. Yeah. Yeah.
Types of liquids, whether you can change your.
Yeah. If you have more questions, we would be around here, so we can discuss more, or like we can connect in LinkedIn as well.
Yeah, I think we are 10 minutes ahead of time, right? So since morning, we've been talking on various topics. Most of them have or touched in some way or the other on monitoring. So the next topic is also in continuation to the same. It's around configuration at scale, right? So at Grab, they're located at various countries and they have large number of virtual machines and Kubernetes. So how do they kind of maintain this when there are deployments? When we talk about monitoring, I think you actually need a solid base system in place. Only then can you go ahead and have a solid monitoring system in place, right? So this kind of ties in with your deployments, with the automation process, and various other stuff. So that's the next topic, which is going to be by Anirudh. And he needs 2 more minutes.
Need a mic for the.
Yeah, while he comes here. Is it on?
Yeah, it's on.
Okay. So how many of you are using chaos engineering in production? You're ready? Okay. Nobody? Didn't want, who doesn't want to take the risk? Yeah. So you're saying cloud vendors and developers are enough to create the chaos? Is a chaos. Okay, application itself is a chaos.
Yes.
Hi guys, can you hear me?
Yes.
Yes, thank you for that. Now, before we get started, let's chat a bit. I'm Anirudh. I am a site reliability engineer at Grab, been here for around 1 year and 10 months. So I'm here to present a bit about configuration management at scale. And before we dive in, anyone who knows what is configuration management, just a show of hands, or who has been into it. Okay. So I think I need to cover a basics as well for that. And let's try to know who all have used Chef, Puppet. I think everyone would have, right? Or guys, okay, cool. So let's start with the basic thing. Yeah. So let's start with the basic thing about what is actually configuration management. These words, what they actually mean. the key thing to focus over here is about states. You have your servers up and running. They have some configuration. They have some current state. And you have some desired state. I want my servers to have a certain state, a certain set of packages, certain set of OS requirements, things that usually a security guys and compliance guys offload for us. So kudos to them. Thanks for that. But what actually is it? It is basically a kind of insurance that you pay today to avoid any unexpected outcomes. You don't want any unexpected outages out of configuration management. You're working on your apps, you're working on anything and everything, but you don't want the other vulnerabilities to be something that caused outage, right? So now we know that configuration management is required. What's the actual need? How does it drill down? How do we relate to configuration management? One thing to note is that, as I said, if we overlook configuration management, then it can cause unexpected outcomes, unexpected outages, right? So, for example, let's try to connect how companies grow up. We usually start, let's say, at a particular set of instances, then span it across VPCs, and then move hybrid in nature. Having a hybrid cloud is very common today, right? So as you have a hybrid cloud, you would have thousands of instances, you have databases, you have compute engines, you have everything and anything. And as the cloud becomes hybrid, you need something in between that fits apart, decoupled, and that helps you manage all these, right? I have all my servers. How do I manage these servers? How do I configure them such that my developers, that anyone and everyone at the team are confident enough to use them? We are confident enough to go forward, right? That's where configuration management comes in between. That's where it helps us get a grasp of the entire hybrid cloud that we want. Right? Now, how did we start configuration management, right? It was quite simple. We spun up some services, so they had some configurations. As these services were spun up with some commands, you could easily come up with an Ansible playbook, quite intuitive in nature. As you have Ansible playbooks, you can directly run any playbook on Jenkins, right? A simple command to run the playbook would work. We already had this running, but still we wanted to explore more. Just because things are running fine doesn't mean that it's all good, right? We want to explore what all tools that we have currently. We want to explore things that can come up in future. We want to know the current challenges that we are facing and we are somehow ignoring, and also predict a few things that can happen in the future. So that's where we started with listing down our key challenges. Other than these challenges that I've listed down, we'll also talk about agentless and centralized environment being one of our major requirements. These key challenges, let's go from a low level from sea level to, let's say, 10,000 level. We'll start from basics of execution environment and go to automation management and schedule management. Right? First of all, it's the execution environment management. Let's say you have every boilerplate template and everything ready. You have your playbooks ready, you have your cookbooks ready, anything. But you need execution environments for these. I cannot simply expect that a single execution environment would work for all. And more importantly, what is execution environment? Execution environment is a set of dependencies that I have in order to run a specific code or any specific executable I want. I cannot expect down the line that I'll be using a single or a couple of execution environments and I'll be able to simply switch between them. It does not go long way, right? I should have at least the ability to use 10,000 execution environment, one for each playbook. I should have that ability. Next, single source of truth, quite important. Anything that I run, I need a central environment or a central platform that fulfills every need I want, at least in the domain that it's giving to me, right? Maybe it cannot deep dive into some stuff, but it should give me at least a glimpse of thing. it should be something like, if you have a problem related to server configuration, you dive in here, you will find at least something, and then you can optimize the solution. So we needed a single source of truth for that. We also needed dynamic inventory management. As I said, we have a hybrid cloud. Every day, you cannot just say that, these many number of instances would increase or go down. You have new services coming up daily, and it's quite intuitive, right? You need a dynamic inventory that is auto-populated. You don't need a static configuration file. And you want this dynamic inventory to be fetched from multiple hybrid clouds, right? A hybrid cloud environment, it should work. Authorization. Simply having playbooks given to all the DevOps engineer to perform an, a drill when, or perform remediation step when an outage works, that will not work, right? I should have the capability to limit a user to view the playbook, to execute the playbook, or to debug further, right? To view the credentials that the playbook used. I need authorization at each and every granular level that I want, that I can have. I need scalability. I should have the ability to run a specific task on 10,000 as well as on a specific instance or a specific container. Schedules and automation management. Schedules are something which are quite common when you talk about servers. You would have some scheduled maintenance, you would have some scheduled checks. You need schedules for everything, and you need them to be automated. And there should be there should be a management for that. I cannot simply say that I'll set up a cron in a server and that would work for me. No, that's not going a long way. You need something to manage all these set of servers, right? And last but not the least, it should be agentless in nature. Our specific use case said that I don't want that if I have 10,000 servers, or let's say I have 10,000 instances to configure, I don't want to rely on 10,000 agents for that, or in sidecars running with each and every one of them. I rather do not want a configuration to be managed separately for the agents as such, right? I should have a central environment that can execute things agentlessly from a central source. And that does not mean I want to limit myself to be, having a specific node. I also want to be highly available, HA environment, right? Now, since we have had these challenges, next we wanted some, key points. What are the things that you are considering when you move towards a solution? Quite intuitive. It should be customizable, cost-friendly. I do not want my budget team to shout on me. Plugins and code refactoring. No developer would like his code to be restructured just because you came up with a new environment. I have my code ready. You do anything. You manage servers. It's fine. But it should integrate with the environment, right? And yes, everyone is good at learning, but we have a time constraint, right? Everyone is here on a Saturday afternoon, so they value time. They do not want to, just keep on doing stuff, right? They want to they want to invest everything in a good manner with a good ROI, as they say. So, as we had so many key challenges, we called our Avengers, and not to our surprise, we had too many tools, right? When it comes to server configuration. And we had to find our very own Spider-Man, the one that fits our multiverse, that fits our use case at our level. Right? So what did we drill down to? We majorly drilled down to 3 major players. Other than these, we also looked into things like AWS SSM, since we were using AWS a lot, so we explored on that as well. But our primary thing was that we wanted to be cloud agnostic. As I said, we do not want to avoid a hybrid cloud, right? We want our focus to be also upon agentless, scalable, and easy to adapt. Something that fits into our environment seamlessly without much efforts to configure it, right? So this is just a quick view you can go through. People, I think, Chef and Puppet, a show of hands who have a good experience about that, or a soft corner for that. Okay. Okay, so others you can maybe not relate much to what Chef and Puppet is, but just overview, it's more about how to manage things from uh, what do you say, a specific environment, and it's more about running commands rather than going into the server from your playbook, just like an Ansible playbook. Okay. Now let's move on to our solution, Ansible AWX, and how it was a solution to us. Just to keep a few things clear, you would also have heard about Ansible Tower being a talk. So Ansible Tower is nothing but quite related to AWX in the sense that Ansible AWX is the upstream for Ansible Tower, right? This is provided by Red Hat, and yeah, it's open source, easy to adapt, and frankly speaking, for me to deploy it on localhost with minimal efforts, it took around 5 minutes plus the download speed or whatever I had. I was connected to hotspot, so you can figure that it was high. So a bit of ABCDs of Ansible AWX before we go into the actual architecture. Ansible AWX has these intuitive stuff like projects, inventory, so it's quite things that we already know. So this is what the architecture looks like. If you see, you have AWX1 and AWX2. These are your controller nodes. Receptor 1, 2, and 3, these act as your executor nodes. This is just a typical example. You can make this architecture even more complex. This is just the basic setup that comes up with when you spin up given deployment of Ansible AWX just via the README that they have. We at Grab, we did customize it, but this is the basic overview of how it looks, right? At a simple level. Okay, so so no one can stop me from doing Docker PS, I believe. So Docker PS is one of the commands that everyone uses, right? So why not give a look about what happened just after I did a basic installation? I had these things simple: Postgres for backend, Redis, you know it, it's for in-memory thing. Tools AWX1, this was the actual container that was running my deployments. You can see that it has too many ports exposed, but yes, again, these are all up to you, how you can customize the entire build. It's there. It's done by a lot of people, customizations. Okay, so let's have a quick tour, right? All talk and no demo does not make sense, right? So let's see if I can get displayed. This would just give you a kind of a tip of an iceberg and help you relate how Ansible AWX is actually working and how is it going good. Okay. So as soon as you log in, again, login methods, you can have various login methods and yeah, use any of the login methods to available auths to integrate with it. This is the simple dashboard that you come up with when you launch AWX. It's quite intuitive in nature. You can filter out things. All the things can be drilled down to a specific job as well. Quick links are there. You can drill down to a specific job, a specific task, and have it verbose and everything. Next important thing is activity stream. I do not want to just be blind about what's happening. I should know what's going on, and I should be able to filter real quick what happened or how did the server configurations change. Right. Let's say I want to drill down an outage. I should be able to go back in time and see that. Inventories, another important part. Inventories, we want that our source should be something about, let's say, Amazon EC2. I want my existing environment to be pulled up via AWS. Sorry for that. Yes. So I want my existing environments to be already pulled up by Ansible. As I said, it should seamlessly fit into my environment. It should have the capabilities to integrate with it, right? It uses STS, AWS STS to pull out things and everything of your inventory. You can, just like any other inventory, you can pass on various variables and customize it. You also have a simple thing like source from a project. You see that option. Source from a project is basically a simple INI file. Let's say I have a GitHub repo and I have an .ini file that is basically an inventory file, and I want to pull in from that. That is also available. Maybe you can use different integrations or tools that populate that INI file, and that INI file is then used by AWX. So that's a good point that helps, relating to AWX in any environment, right? Yes. Moving on, next we would have workflows. Workflows are something that Ansible AWX helps you relate a lot. Workflows, as you can see, these are just a basic set of jobs. This is just a simple output, but as you can imagine, this can grow complex in nature. This helps you manage a lot of things, right? I want my tasks to be easily visualized, no matter how much their level of expertise is, right? Everyone has a different expertise. I do not want that someone should have a level of expertise of AWX just to view this, right? So this visualizer, it helps down, streamline everything. And as you see, these are simple if-else. You can add if-else statement. If it passes, do this. If it fails, do that. In all cases, do this, that. So control flow is there. I hope my scripted demo would show that. Okay. Okay, yes. So this workflow, if you see the details, these are basic notifications and everything you can set. And each of the workflows that you saw, each block that you saw, drill down to a job. And each job, as you can see in the top corner, it's written the job ID and everything. You can set an execution environment for that. This helps you, scale up a lot, right? When you scale up, maybe you wrote a playbook 5 years ago, right? You have an execution environment for that. 5 years down the line also, again, you want to use that playbook. So that option, this execution environment helps with that option. You can go back and use the same thing. Yes. So it also gives you execution node and what all happened and everything. Output is also intuitive. You can log in there. It is very much integrable with various things. This is just a basic setup. So you can drill down to things about how to integrate. And organizing your teams into users, teams, and everything is there. You have user auth and everything that you can have. Right? You can integrate your existing authentication environments with the authorization or authentication environments with this. You also see the credential section, right? So credential section also helps you customize a lot of things. Let's say I have 10 SSH keys, just to give you an example. And I want to use them as a single credential. These 10 SSH keys should act as a single credentials. What I mean is, I run a play, I pass this single credential, and it switches between 10 SSH keys. So that is available in Ansible AWX. You can simply pass in a configuration of that credential. You configure how that credential looks like, what it uses at the backend, right? So just to give an abstract idea, it helps you come up with your own credentials. You can also pass in SSH keys or direct credentials like Git credentials and everything as well. These are encrypted via AES, I think 256-bit encryption. Not sure, I looked at it a long time back, but yes, it's well encrypted. So, okay. So now we have a basic view of what's happening at AWX, right? How do I change my slide over here? Okay. Now AWX at large scale. We are talking at LSP, right? LSP is the stage. How could that not? How could we not talk about scale? Scale is very much important now. How does it help? These are the basic, use cases that these are the basic use cases that we find that everyone could relate to. Everyone needs a server initial configuration, and yes, you spin up new servers at least hourly, I say. Deployment of monitoring agents. It's very much important that you have your sidecars, as they mentioned about Thanos needs a sidecar, and it's true. Every one of them needs something of or the other agent to go there. So AWX can help it function well at large scale. Other are simple OS patching and agent-based patching. AWX helped us a lot in these aspects, in automating all these, and since we have a hybrid environment, it easily adapted to that hybrid environment. How did it adapt? It could simply, just as I said, it could use custom credentials. It also had the ability to have a dynamic inventory and pull from various sources like AWS, EC2, or let's say a static resource as a inventory file. And how did it actually benefit us? It benefited us in many ways. These are just a tip of the iceberg, I would say. It helped us with a centralized and yes, agentless execution environment. I do not want all my developers or anyone to execute anything locally. Right. You strongly do not want that. There should be an option, but you would prefer to go via a central environment, as we talked about. Dynamic inventory management, again, very important. As you scale up, scale down every day, you need it. Agentless setup, I do not need a configuration for configuring, right? Completely automated jobs and interactive workflows. Yes, so at Grab, we were already using Ansible playbooks and something that could help us interact with the events. If you see in an Ansible playbook, the execution consists of various tasks. Each task would have an output. It would have an source code, what you say, and the initial configuration and the parameters it passed. So it should be interactive enough to help me drill down at the very verbose level. And access control, yes, everyone wants access control, right? Otherwise, security folks would bug us. So yes, that was about Ansible AWX and how we use it here. So any questions? Yeah. Sorry? Okay, so operating Ansible installation has two ways. You can either use a simple EC2 instance or pull it up in a containerized environment, as I showed, or you can also use it via EKS. It is very much integrable with Kubernetes environment. If you see the installation steps, they rather prefer it going via Kubernetes. So yes, we use it currently at EC2, we are also planning about EKS as well.
Upgrading your Ansible AWX.
Okay. Sorry, I got your question wrong. So currently we do not have any such roadmap to upgrade it recently in the coming days. But yes, how we plan to upgrade is that since it has multiple nodes, so it helps us, as you can say, take one node and upgrade it, take another and upgrade it. There are options. We are yet to do it at our end, but yes, it has an option to do that.
Next one would be that you showed that you have configured it in a controller and other distributed nodes, right?
Yes.
How are you scaling them up and down depending upon the load?
Yes. So we have two things. First is when you deploy it via Kubernetes, you can specify in the Kubernetes configuration how to scale up, scale down. In your EC2 also, you can, when you come to EC2, you have a trade-off, right? When you don't want Kubernetes, that means that you are somehow managing it at your own end. At our end, how we did it, we customized the image, we set up alerts. Since this was open source, so we were very happy to do anything and everything with the Docker image, right? So we customized it to have alerts for that. And then based upon that alerts, we had different events to help scale up, scale down. So just one thing, we do not want AWX to again, ensure high availability for itself and alerting for itself. We had our monitoring system, so monitoring system should do that. So we integrated it with it. RBAC. Yes, role-based access control, it supports. AWS IAM can be used there, and it uses STS to go to IAM and then assume the role. We used it to fetch our inventory. Again, we don't want it to have a lot of permissions for that. One thing was there, we only gave it the read permissions, not write, and yeah, RBAC helps there.
Yeah, here, left side.
Yeah.
You said agent-based patching.
Yes.
Could you highlight that where exactly we can use?
Okay, agent-based patching. Let's say you have a server up and running. You have your requirements that whenever a server comes up, these are the other agents that will run with the particular server. Now, these agents, maybe it's due to your compliance requirements or anything, also need to be patched. Let's say you are in a banking environment. The banking environment has some regulations, right? So I have an agent. I have it running maybe for monitoring, maybe for anything, maybe for compliance. Now I want the configuration of that agent, and I want to patch that agent in place rather than patching the entire server itself.
And also you said it's better to set up agentless setup.
Yes. So why?
Contradictory kind of.
No. These are two different things. First thing is, let's say I have a virtual machine, and wherein I have different things deployed. One of them is my app. Other are my agents, or agents monitoring the app and agents helping the app. Correct. The other thing is about when I patch these things, I want it to be agentless. I do not want to deploy my own agents inside this server, inside this VM. Are you able to relate? Yeah.
Serverless, we are not managing, but AWS managing for that. In similar way, you are saying that no agent, but agent is there. Like in the laptop, like so many agents or services, if you running, then for your application, you are also getting data from that agent or pushing the agent.
No, I am not getting any data from the server. I'm pushing to the server.
Yeah, then why you are saying agentless? Like that's what is the question. Like when we say serverless, just we are not going to monitor the server. It is the AWS which it take. Like when we find the Lambda take that request, it run on any server. It can start the server, 1 server, 10 server. Then what do you mean by agentless here? Like you say that we does not require any agent to update on that server. Or agentless update.
Let me answer that.
Yes.
So AWS is Ansible uses protocols. So for Linux, it uses, you can use SSH-based protocol. So you explicitly don't need to install any agent, which a Puppet or Chef does, or a Salt Stack would do. So you do not need to explicitly install any, and through SSH, it will connect, run its remote execution like the commands and everything, whatever you want to run, and come out. Similar is the case with Windows. So it uses WinRM. So WinRM is the Windows Microsoft provided protocol which is running. It will use that protocol to log into your system using your credentials. Whether you can use either password, you can supply password, or passwordless using SSL-based key-based authentications and all. So it will connect, get into the system, run whatever is the commands you have provided. So Ansible will play all these tasks are there, which would have the components which can means convert the command sequences which are in the YAML format into your command sequence and run it. So there are various things. So that's the reason why AWS is agentless as compared to other configuration management tools.
Thanks. Yes.
So that is going to cause a lot of limitation in managing your infrastructure, for example. As he rightly pointed out that he's speaking in a lspe event where the topic should be large-scale production engineering, that you need to manage hundreds of servers at scale, right? Using Ansible, so personally, I do not support any of the configuration management system that you mentioned here. Sorry for that, but the SSH is the bottleneck here because you cannot manage more than say 10 parallel SSH connections on a normal production system for upgradation.
Well, no, that's not the case. It's about parallelism. Yeah, you're talking about parallelism. So we send around 50 to 100 servers in one shot.
Yeah, so that is going to choke your server, right? You cannot.
No, it's not going to choke because it's all in clustered mode. So parallel executions happen. And if in case you're on a Kubernetes cluster, you have 7 to 8 containers running, they take the load.
Then I understand that. You open. Yeah. So Ansible, the Ansible itself is like I said, he said agents-less, right? Uses SSH. If you get into, if you say minus BVV when you run Ansible, you'll exactly see it's actually making a connection using, like, it uses SSH multiplex.
It's a multiplexes connection. Yeah, correct.
So if you have, when he's talking about 100 connections, you're just making 100 SSH connections from a box. And that too, if it is a scalable system,
it has concurrent jobs as well.
It has concurrent. So if he has 10 boxes, maybe if he says 100, maybe 10 connections per box. That's very less actually what he said. So we can run more than that.
So if I have, let's say, hundreds of machines which I need to manage through now.
You have 10,000 machines.
Okay.
So if you have
how the multiplexing of SSH is going to help me here?
So you have a connection which you make in one call, right? By default it is 5. Correct me if I'm wrong, right? Ansible has concurrent connections by default 5.
Yeah.
So it can make 5. In our case, like when I want to, if I have to do it like 100, right? I'll probably run about maybe 50 or maybe 100. How much are based on my vertical scaling of my machine? Right. Like if I use, for example, if I use maybe like an 8-core machine which has a good network bandwidth and all that, right? Network is what you require and a little bit CPU there. So I'll make it maybe about some 25, 30 or something like that per connection. And then when that, as in the jobs close, right, those connections close and new ones open for those blocks. So effectively, if you see, right, then multiplexing also, the time is 1 minute. Again, correct me if I'm wrong. It's 1 minute. 1 minute, if you don't make any connection, those connections close off. So that way, the FDs, the file descriptors are always in control. I have not seen it going like above maybe 15, 20K is what I have seen. You're not doing that one. So that way, it works pretty good.
Yeah, but you are limited to time constraint as well, right? So at one shot, you are going to control, say, 50 servers at a time.
Oh, that we can manage. That's a strategy. That strategy we can manage.
It is going to be like hours of upgradation that you are maintaining, right?
Oh, no, not really. See, you have, say, 100, right? Like if you say, right, if you take 10 and let that 10 make another 10 connections, if you cascade it. So in 2 iterations, you finish, like, it doubles up. So it's a strategy what you use. Ansible, what they're talking is just a tool which is just making one connection. Like if you're in Yahoo or if you're working.
I just, getting clarified on a slide that he mentioned that lspe cannot, I guess if you go to the couple of slides back, so large scale cannot be done agentless. That is what I understood from his slide.
No, this is.
Can you go one slide back as well?
This one?
No, go back. Where you have list of points, maybe.
Early, is it?
Okay, I got AWX at large scale, this one.
So AWX at large scale, where you mentioned the last point as agent-based patching, right? So if you want to go large scale, you want an agent, that means, or?
No. These are two different things that.
Or maybe I misunderstood that you need an Ansible agent to do a large scale.
No. These are the agents that you already have running in your environment, and I want to patch those agents. Yes. Interesting discussion.
I'll give you a scenario for agent-based patching.
Yeah.
Now, when we talk about vulnerability management and assessments, there's always a tie-up that SSH and everything, we go in a little lazy manner. When I say lazy manner, you will not go granular wise where you pick up a vulnerability and check for what is the RPM or the package or the KB to be applied, and then do it. We will go it in bulk. Just go run a yum update or zipper update, or go and do update Microsoft, right? But in case there are some components which needs to be, which to some of the vulnerability remediation or the endpoint remediation tools they have. You take Qualys, you take BigFix, you take Case. These all come with specific sets of commands and executions which will be more specific and very granular to fix your vulnerability. In that case, if you want to run that at a particular, yeah, I would say a vulnerability remediation, that also can be triggered through Ansible remotely without logging in. And that will go run that particular play or particular command sequence or whatever is the way that agent will understand and fix or patch your system. So in that place, the agent comes into play.
Yes. No. Yes. Agent patching is something it's related.
So even say, for example, you have 10 steps in an Ansible playbook, which is going to be executed across, say, 10 machines parallelly. And that Ansible playbook is going to take, say, 45 minutes of execution time. And you have hundreds of hosts to patch. How much time you are going to spend in patching those servers?
You're explicitly what you're doing is it goes pretty fast. Right?
Pretty fast means I have the number,
parallel.
45 minutes
So
is the time.
45 minutes of time, you give a timeout, and you're saying 10 steps. 10 steps go in bulk to all the systems.
No, it's not actually. It's not. It's going to 10 servers at a time, 45 minutes each. So if I have hundreds of servers, how much time you are going to
You have concurrent jobs. As soon as I execute or launch a job in AWS, I have an option to select number of concurrent jobs I'm allowing. Let's say you said 10 concurrent jobs. I can increase it, right? If I have 45 minutes of execution on a node, I can say number of nodes equal to the number of job executors. So that brings it down to the specific case. If you are saying that 45 is the bottleneck, then it will bring it down to 45. It will not go up. Yeah.
It's actually very...
See, actually,
Microsoft has the problem.
Digging down onto the same point is, so basically I witnessed a very critical production issue because of the Ansible agents grabbing up, SSH. It's choking up the system altogether. You have no port open to SSH to a production machine to debug the issue at all, right?
So you can, maybe you are missing on the SSH configuration part. You can set upon the, TTLs and everything, right? So that could help. That could be the bottleneck. I don't understand. Maybe you can reiterate or how it's going.
We have that option of parallelism also, right?
Yes.
Concurrency is one part, parallelism is another part.
Yes.
Two job configurations have that two sections.
Yes.
You can have a combination. So you can split it accordingly, and you can put timeouts also inside the job template itself, which would actually make sure that, okay, it runs this set, monitors the job which has running, what is that, and continue the... So it splits up into multiple sections and can run more.
Got it. Yeah. Okay. Thank you.
Nice. Okay. Any other questions?
Yeah. I just had an observation. If you actually go to tens of thousands of servers, you will actually tend to build an image and just launch it across those machines rather than running so many jobs on so many machines.
That is also a solution, yeah. It's up to you. Oh yeah, he has one.
So yeah, in terms of Ceph and Puppet or other configuration management, right, you have some kind of state management, right, where maybe at least you know what version was installed there, and at least there's no changes on whatever was installed. Like in Ansible, right, we know that anyone can go and, like, once the Ansible, like, whatever has been configured, maybe someone can go and change, right? Like small version also, like, it can be upgraded again. So how do you make sure like that they're not changed at least, and as it should be as it is, like how you want.
Yes, so that's where I use the execution environment. I put in all the constraints, that these are the constraints specific to my job and these are the constraints that it would use as its own execution environment. So that you move out of that dependency and you rather couple up all the dependencies in a package and use it altogether. Okay, so your execution job would already have that execution environment. And these execution environment are easy to make. It's simply just like a Docker file. You have some certain commands, right? So in this, again, you have an image, they say, in Ansible AWS. You can pull in that image to have all your dependencies, and that would work. I hope that answers. Yes, Ansible AWS is completely open sourced. The enterprise version is Ansible Tower. Yeah, Ansible Tower has a couple of things more, but for our use case, we wanted open source. We wanted to customize. AWS was there for us. Architecture.
The architecture one, architecture.
Yeah. Just. No, I think this was the next one. Yeah.
I don't have a question. I just want to.
Yeah, this is from the actual installation guide that you have. They have it there in their Git. Okay.
Any other question?
Okay.
Cool.
Okay. So before I close, just a few things, since there were a good number of questions. I also had things to ponder, and I'm still pondering about. These are what I think about. AWS versus Jenkins, people usually come up with, is there an option? Should I choose between two? No, it's not. It's use the best of both worlds. Jenkins, you use it for its best. You use AWS, wherein, let's say, you have an Ansible specific playbook. You want Ansible, you use Ansible AWS, it would work seamlessly. Configuring backup, how do we configure the backup of this? Again, it relates to HA. How do you ensure high availability of AWS? So it can be configured for high availability. I think a couple of folks asked about it as well. You have an option there. You can configure your AWS. You can think about that. Last two things are, one of these is the AWS, the GitHub issue that I found that is very interesting for me. And the second one is versioning of inventory, template, and project. So I should have not only the option for static inventory and dynamic inventory, but I should also have a version control of that inventory. Go back in time and not only see the jobs, but also bring that inventory back and have a versioning across these and decoupled as well that I can relate to and point in as a flow. So that's all from my side. Thank you everyone for being patient after having your lunch. Thank you.
Thanks, Anirudh.
Okay. I think we've completed on time, or rather early ahead. It's your 4 o'clock. Thank you, everybody, and thank you, Grab, for hosting us. And anybody interested? Anshu, are you still on the call? Are you still around? No, I think he's 2.5 hours ahead of us. So probably his tea time. He's not around, I guess. Yeah. Yeah, I think it's. So yeah, thanks to the Grab committee again for hosting us, and anybody else interested in future, feel free to reach out to Anshuman and Debanshu, and thank you all again. Thank you.